Gotta turn my mic on. And subsequently mute it so I can't hear it. Alright. How's everybody doing? I found this very, very cool rotifer that lives in a tube. Hey, Myco Learning. This is from my pond in my backyard. And you can see it has the characteristic corona, which is the cilia that are around the top part that it uses to pull the... It's contracted inside of its little tube. There you go. You can see it's actually living in this tube of its own making right here. So this one isn't going anywhere. When it gets nervous, when I bump the desk a bit too hard, or when I... a little bit like a turtle. Turtle's a magic word on my stream. You can see whenever I bump the desk a little too hard, or if I change the magnification options, it will contract and it will pull itself back into this little tube right here. And when it wants to feed, it brings itself about 3/4 of the way out, so there's still a foot back here, and it's got its body, and this is the head part. So around the mouth, surrounding the mouth, it has this sort of whirling cilia. What it's trying to do is actually generate current. So it spins its little hairs around its mouth super fast, Bellum and Freeman, and it uses it to create a little gyre. You can see stuff get kind of pulled into it, and then occasionally things will escape it. So this poor little green algae is trapped in the gyre that it's creating. And it's using that to try to eat. Not everything goes into its mouth, but we can zoom in nice and close, and you can see like a water type Pokemon, yeah. This is its Mastax, which is what it uses to eat with. Yeah, it's like creating a tiny little whirlpool, and the little hairs that surround its mouth is right in here, so some of the stuff gets dumped right into the inside of this little cone, which is where the hairs are waving. So they're sort of doing this, and it looks like they're rotating, but in fact they're they're just waving like my fingers back and forth, right? And it creates this little whirlpool that stuff can get sucked into, and then some of it gets pulled into its mouth and gets chomped by this thing in here. And the chomped stuff goes into this. There's the digestive bits. So this is all material that's been consumed, and then it just works its way through, and the tube that it lives in ends up being open on the other end, so waste can come out. But you can see it actually has a bunch of. Ooh, that's really cool. It just whipped out a little antenna off the top of its head right there. It's using that to sort of sense what's around it a little bit. Oh, maybe that was just a piece of something that's stuck on it. Usually have a little antenna that comes out right in here somewhere, so maybe this one just has a short antenna that they use to kind of sense around. Is the spinning bad for algae? Well, the algae that are in the whirlpool that gets sucked in is very bad for those. So, do they get sick? I don't think so. It's not that kind of corona. But they can decide that they don't want to eat whatever's come into their mouths. So sometimes they will reject particles that are too big. You'll sometimes see things hit them in the face as a result of the little spinning particles. So if they get smashed in the face hard enough by a large enough particle, they'll actually scare themselves and contract back into their little cave that it's coming out of. So this is a really interesting rotifer. Like I said, I've never seen one of these in my pond, but they are a lake organism. I think it's. I was just Googling a little bit before we started, and I think it's the tube-forming rotifers are in a little genus called Limnea or something like that. Getting smacked by your own food, right? Exactly. Gotta be careful when you're making a whirlpool around your face. How do they react to lead? Well, most organisms don't do well when you put them in where lead is. I'm not sure what you're asking, but I don't think there's any lead in my swimming or my koi pond. I don't think that's a normal component. Oh, look at it. It's like a giant skirt almost. Look how big that thing is. The corona part that just wraps around. It just looks like a conveyor belt, but I promise you the little hairs that are there aren't moving in a circle. They're just basically going back and forth. But this one is just really, I don't know, that's really beautiful. Let's see, can I go down any farther? Oh, it's right at the edge of my field of view. So let's see if I can move it this way a little bit. And we'll move this little bubble up here. Now you can see the tube that it's in. From this point of view, you can see that it's this big long thing. It's way bigger than the organism itself. And so, yeah, it's a huge corona. And pretty different than the little rotifers that we usually see. This one's huge, by the way. It's a really big rotifer relative to what we usually see. So this is 20x. Let's see if I have 20x, no multiple. It's about that big. And so, if we, oops, I want to see if I can move this little. Yeah, there you go. So you can get a sense of it. This thing's probably total size is a half of a millimeter or so, like roughly in that size range, which is pretty big for a rotifer. So if a ball of lead would get drawn into their mouth, would they spit it out again? Well, lead's unlikely to be in the water in terms of a ball, but I'm sure if you put little balls of lead around there, it probably would spit them out. The general mode for most rotifers is just to eat everything, unless it's too big to fit in their mouth. And then if it's not something that's food, it just passes through them. So it's a relatively easy way. Yeah, most organisms don't handle like lead in particular very well, but it's usually sort of a long-term poisoning effect that affects in humans. It affects our neural functions. So I don't know what it would do to a rotifer, and I don't know that people just expose animals to weird things like that. How would it handle plutonium? Oh, you might be surprised. I know you were thinking plutonium would definitely kill it, but the rotifers are highly resistant to irradiation. And I don't know about this genus in particular, but the Deloid rotifers actually are one of the most tolerant to like radioactive energy organisms on the planet. And I think they've been shown to be more resistant to radiation than even water bears. I don't think they enjoy it, but I don't think it's as harmful to them as it would be to us. Um, it might make them grow. I don't know. Um, how does it handle being gold plated? That would definitely kill it. Unfortunately, if we wanted to look at it in the scanning electron microscope, Freeman, I'm I'm pretty sure it would just look like a deflated balloon by the time we got it in there. But it would be a gold-plated deflated balloon. In order to get these really soft-bodied organisms in a scanning electron microscope, you have to do some really clever silicification of their cell walls. And it requires this sort of like, I don't know, intensive treatment where they basically expose the body. It would be still be dead, but they expose the body to these like silica treatments that basically impregnate the outer cells of whatever it is, and turn them into hard objects. And do they dislike soap? Are we just going to go through everything that they might be exposed to? I would say most organisms in water don't like soap. Do they sleep or do they just eat constantly? I think they have resting stages where they are relaxing. But as long as there's food available for them, you know, the energy that they're expending has to be matched, basically. But I think that they, it's like sitting on the couch eating Doritos, right? You could probably do that for a large chunk of your day if you really wanted to. The eating part's not really that energy expensive. Hey, Samchung. How do they procreate? A lot of the rotifers lay eggs. And you just sit on the couch and wave your fingers like this, and then the food would fly into your mouth, and then you could just eat it. Seems okay. It built the little tube that's around it, so let me back out to full size and show you the actual tube. But it's actually quite large relative to the body of the organism, right? So it can fit completely into that tube and still have a little bit of extra room. But they built it. How many sexes do they have? For most rotifers, I think they have a sort of broken wheel lifestyle, where they will reproduce eggs that are clones, and then usually some conditions will happen. It'll cause some of the eggs to be converted from female to male, and then they'll have sexual interactions part of the time. But they can actually be mostly female for many generations, and then a male will be present to sort of switch to sexual reproduction. And the Delloid rotifers, which are the ones that are a little bit better at handling radiation than these guys, are all female. They don't even have a male phase. They just do they just lay eggs basically as clones, and they never interact with it. Never have to interact with anything else. Can they turn in the tube? I don't think so. I think that the tube is too small for them to flip themselves around. So these are good questions. Do they have house parties in their tubes? I don't think they have any house parties, but I guess you'd have to ask their neighbors. In this case, it's like goldfish and some Bordetella and maybe some other rotifers. My guess is they probably don't let anybody in the tube unless you're dead. So I think it would be a pretty boring party. But I guess we could just watch it for a few hours. It is a Sunday night, and see what happens. And see if they have a party. My guess is they won't, though. I'm gonna guess they just eat and then maybe just hang out inside their little tube. A little bit more relaxed lifestyle. Hey turtles, how's it going? We're looking at a little tube rotifer that I found in my koi pond. It's living inside this big brown tube that it created. It builds it out of debris mostly, so it's made out of like organic material, and then it has a place to hide. Yeah, like a vacuum tube. Tube parties are where it's at. Could be. It could be. I don't know. I haven't been to a party in a long time, so because I'm old, but it's possible. Is there sexual selection? You mean, do they choose mates by like how well they built a tube? I doubt it. Probably just being able to survive in the environment is their primary version of selection. But I don't know. You're asking me a lot of questions about an organism I've only just found. So, so I don't know the answers for this particular group of rotifers. I'm lucky that I recognized it was a rotifer. I mean, it has all the characteristics of a rotifer. So it has a corona around its up here in the anterior end. It has these little cilia. That's usually a clue that you're looking at a rotifer. And then this thing right here is called a mastax, and that plus this is definitely like you're in rotifer territory. And then they usually have a really simple body plan with little toes, but this one's toes are inside its tube, so I haven't been able to see the toes. But they usually have one foot with like 3 little toes, or sometimes 2 little toes, and that's what they use to hold on things with. But if it runs out of food at this location, it probably could use. Many of the rotifers use the corona to propel themselves across the water to find a new location, and then it might have to build a tube again once it gets there. So, and if we just move the microscope a tiny bit, I'm just gonna move it over here a little. This little glowing thing right here, and then there's another one here and another one here, and they're all along this. There's one right there. Those are diatoms. So that's a diatom. This is a diatom. This little guy crawling around right there, that's a diatom. And last time we sort of checked in on my koi pond, the diatoms were mostly dormant, but these ones have chloroplasts. And do the diatoms attack? No. Oh, hey, Dr. Derp, how's it going? I should be giving a shout out to MicroLearning. There we go. Gotta pay attention to what I'm doing, and also Dr. Derp. Hello, Derp. I typed it Drep. There we go. You should check those guys out. Things are going well. I had a pretty busy week the last 2 weeks, so I've barely been able to stream, and so I thought I'm sort of in taking a break mode, so I thought I would take a little time and check out what's in my koi pond. And I found, ooh, that little green guy that almost got sucked in is a Euglena. Let's see. There's our rotifer. And then this little green guy right here is a type of Euglena. There's a diatom just hanging out, drifting, crawling. This little green guy right in the middle, right here, that's a Euglena, I think. It almost got sucked in again. It's right on the verge of getting sucked into that giant gaping mouth. Are diatoms crunchy? Absolutely. It's on the struggle bus. It's like, I'm gonna fight the current and get away, and then it gets so far, and then it just gets sucked right back in. So Euglena are sort of teardrop shaped like this one here, and they have a little red dot. That's usually like an eye spot that they use to detect where light's coming from. And then they have some flagella on their body that allow them to sort of crawl around or wiggle around. Euglena are kind of interesting because they are they can be autotrophic or heterotrophic, so they can basically switch around between which type of food source they want to eat, and they can switch between food that's sunlight, and what's around them. Oh, it went. Now it's stuck in the current again. You can see it's having a day. There, it keeps getting caught in that current. It's playing with fire because I feel like one of these times it's going to go into the mouth. How's it going, Mrs. J? I gave you a little shout out there. If you're not following MicroLearning, by the way, she streams about mushrooms and with a microscope, and Dr. Derp usually streams right now from his 3D printer, and Devil and Mrs. J is like a crafting specialist, and she makes things. She's got a pretty cool stream you should check out as well. These little spiky green things that aren't being sucked in right here. Oops, let me zoom in. So there's our Euglena, also still being caught in the vortex. This little thing right here is a type of algae that takes over my pond because there's a lot of fish in there, and they poop in the lake, and they eat a lot, and they generate quasi-eutrophic conditions. And this little algae is called Cenedesmus, and you see these little spines that are right here that are coming out from the Cenedesmus. Those are flotation spines, and they are usually filled with little gas vacuoles that let the algae float up towards the light. And Cenedesmus are a type of green algae. And you can see the there he goes again, just narrowly avoiding being consumed each time. You think maybe they're just riding it around on purpose? You think maybe it just likes it, and it's like, ooh, whoa, almost got sucked in there. I think maybe it's like a roller coaster for them. They're like, ooh, the rotifer's out. Guys, let's go take a ride. Or you think maybe it's just dizzy and it can't figure out which way is up because it keeps almost getting sucked into its mouth. Now it's on the back side. I think it actually reached safety. If you got on the other side, yeah, I feel like maybe that it got away. This is pretty fun. So there's Cenodesmus all over the place. There are these little spiky things with 4 cells. And they can grow up to 8 colonies of 8. Have I done any stuff with microfluids? No. Well, I don't know that it was trying to eat that thing, but it is still pulling stuff towards its mouth. So here's a little diatom crawling around right in the middle. You can see most people don't think of algae as being able to crawl, but diatoms have this ability to crawl around. They're motile, some of them. So they look a little bit like Saturn. Well, this one, when you're looking at them in very low resolution, so I would ramp it up. I could make them much closer. They would look a little bit more impressive in the SEM, of course. And then there's some algae. That's Cladophora. There's some more algae right there. It looks like maybe that's a tiny oscillatoria or something. Can't tell for sure. And there's another diatom right there in the middle, a little boat-shaped guy. Is this an expensive microscope? Yeah. I mean, if you have a spare $20,000, you could buy one. But you don't need to have a microscope that's this nice to see stuff. You can get pretty good images of things like that rotifer without spending more than like $100. The difference is that we're looking at it in high contrast, and I've got a very nice camera attached to it. There's a little Vorticella. Let's zoom in on it. So Vorticella have a similar strategy. Yeah, for 20,000 you'll just squint. Yeah, I mean you can if you want. Vorticella have a similar strategy. They've got, they're like a little tulip or something, a little flower bell. And then they've got a tiny little stalk that they can, that's like spring-loaded. They can pull themselves in. And then this bell-shaped thing with a ring of cilia around the top of it, which you can't really even see. They just look like a blur right now because they're moving so fast. But you can see they're also creating a vortex of particles that are moving towards their mouths. So I'll try not to cover any in lead or gold. You have to go to sleep like a wimp. Oh, I was going to stream a little bit earlier, Maiko, because I thought, oh, maybe you'd like to see some of this stuff, because I know people in, on the other side of the Atlantic wouldn't be able to stay up much later. But thanks for dropping in, and at least you caught a little bit of it, so it's very nice. I'm going to zoom out so you're not wondering where I'm going all the time. You can see all these little guys on the ends of this thing. These are all diatoms. All of them. Those are all diatoms. Each one of these little things sticking off of the fringe. Here's one as well. And they live on a little stalk. Those are Gomphanema johnsonii. And there's a bunch of them, and they're all the same species. Many of them are probably clones of the same organism. The diatoms are... They form the base of the food web, so there's a lot of stuff that's trying to eat them. And they resolve that problem by just cloning themselves a lot. So they can make, in ideal conditions, they can make them, many, many copies of themselves in a single night. So I usually don't fret too much about killing a few of them. They're just clones. So, but they are a food source for most of the things that we're looking at in here. You can hear somebody's upset about something in the other room. Let's go for a little look. Or, oops, hello. Hello? I don't know what that is. Some sort of ciliate. It's moving too fast for me to capture it in the frame of view in focus. There's a bunch of little ciliates in here, and also heterotrophic nanoflagellates are pretty common. They look like little circles, and they just kind of zoom around in the water column, and they move really fast. This guy, that's a little heterotrophic nano. Pretty small, kind of hard to see any of the details on them, so I usually just skip those. I collected this sample a little bit earlier today, and then from the pond in my backyard. This is a little pond. And then I brought it in and let it warm up for a while, because the water is still kind of cold. And I think a lot of the algae, basically, and zooplankton that are in here, the ciliates and other things, they don't do so well when it's really cold. The diatoms are okay, but the rest of it's not so much. So, Captain Rex and Boba Fett would be said. Are diatoms evolving visibly over human time frames? Well, it depends what you mean by human time frame, Freeman. I have some evidence from sediment cores in lakes, and I'm not the only person, but we have evidence that diatoms have evolved over the span of about 4,000 years from one species to another, and somewhere in the sort of 2,000 to 4,000 year range is kind of what people have observed. So, and there's a lot of diatom species that we have to treat as like a species flock or a species cloud, because there's so many of them that are so similar, but they haven't quite separated from each other enough that we would call them separate species. And I imagine if we give them another 1,000 years or two, they probably will. So, to answer your question, sort of, like they sort of are. It's a little tiny rotifer, I think. Yeah, that's a rotifer. You can see this is a Delloid rotifer, and it's kind of groping around with one foot and then pulling its body towards the direction that its foot is groping into. Oh no, that's its head. Yeah, that's its head. Its foot's attached right now. But that's a Delloid rotifer. Those are the ones that are pretty good with radiation. Pretty much anything that can dry out is pretty good with radiation. Here's a big old Vorticella too. Let's see if we can zoom in on this little guy. You never understood what differentiates one species from another. Well, there's a lot of different ways to separate species. But a primary way that people use is just trying to figure out how different they are and whether they're different enough from each other. But like anything, Panda, people determine what those boundaries are, and it's somewhat artificial. It's like If I gave you something that was halfway between red and orange and I asked you what color it was, we bin things into colors, right? And so we have to decide whether it's orange or red, and then some things are reddish orange. So, I guess if we find that it's different enough from something else, then we would separate it. But it's a little bit of a gray area, and that's why there's people who sometimes argue about whether something is a species or not. It's because, functionally there's this sort of slight differences between things. And then people have a bunch of different possible ways that they have observed things that they think help define whether it's a species or not. So, for example, can they interbreed? And usually if the answer is yes, then it's not a species. It's not two different species if they can produce viable offspring that can also produce offspring. So they generally they think of that as being a species. Two things can interbreed and produce an offspring, and it's not a species. So, for example, mules are that way, or hinnies. But our model is kind of difficult to define perfectly. That's just some bacteria eating away at the inside of a algae cell. It's kind of interesting. Get a sense of the high contrast from the scope. So, COVID evolves distinct variants on a year-long time frame. Well, that's because its replication rate is much higher, and it typically things that have very short replication time frames can evolve much more quickly. To get to your question a little bit, Wabu, if you encountered a new group of people who'd been living on an island and they look like humans, but the smallest one as an adult is 9 foot tall, and the largest one is 15 feet tall. Is that enough to separate it out from the human species? And I think most people would say yes. Even if they had most of the same characteristics, because those organisms would be giant-sized. They would be from 9 feet tall to ranging up to 15 feet tall. And the tallest humans are like 8 feet tall. So, we have a range, a size range. And so normally you would separate those things, I think, as something different than humans. So just to give you an example of just using morphology as a tool to separate groups of things. And we do the same thing with diatoms. So if I found the size range of a population, and there's no overlap between the size range of one population and the size range of another. It's exactly the model that I just gave you, where humans might range from something like 2 feet tall to 8 feet tall. The smallest ones of whatever these things are, giant like humans, went from 9 feet to 15 feet, right? So they just don't have the same size range. And sometimes just that one character is enough. And most people would argue that that's probably a different species. So, yes, Homo shaquillus. Very large organisms, like enormous organisms for humans, but they don't really fit our size range. And so, you can use the classifications or the characteristics of size just by itself as one aspect that you could use. what happens if the size range went up to 9 feet tall and went down to 4 feet tall? Now there's a lot of overlap between the two, and I think you just have a population with a very large higher end, right? So we don't have humans that are 9 feet tall, but if we found some on an island like that, then we do. Because a lot of their size range would overlap with a lot of our size range. And I think if you found something that was 6 feet tall, you wouldn't be able to distinguish, is it a human or is it one of these other things that we found on this island, right? Even though there's a higher upper end and a higher lower end, there's so much overlap that it would be challenging to really separate them morphologically. Now, if there was some other aspect, like they had horns, or I don't know, antenna, or they had a different sensory organ, you probably would be like, oh, that's definitely something different. Because you could always distinguish it even when the size ranges are overlapping. So it's hard to tell that your 6-foot ladder isn't your dad. Well, I mean, I guess that's your dad's got a lot of rungs, and I mean, if he's 6 feet tall and the ladder's 6 feet tall, I can see where you might run into trouble. Is he also made out of metal, though? I assume similarity, chromosome count, also, yes, all kinds of genetic stuff come into play. I was just talking about morphological species. And sometimes morphological species is not the best tool. There's an example. One of my colleagues, Evelyn Pinsel, found a bunch of diatoms that all overlapped in size and overlapped in characteristics. And when she ran the genetics on them, she separated out something like 32 different species because genetically they were very different from each other. And we usually refer to those as cryptospecies. The species that look similar to something else, but when you get to the genetic level, they're different. And that's another tool that we can use. But the problem then becomes, how different do they have to be genetically to separate them? And do we always use the same tools, the same distances to help characterize that? And the answer is probably not. So it becomes very challenging just to use the genetics and nothing else. And it's also sort of challenging to just use morphology and nothing else. So usually we try to combine as many pieces as we can. But I think if you if you only have fossil stuff to go by and you don't have the DNA, then you don't have any choice, right? So there's not really a lot of decision making that needs to be made at that point. You just go with it, right? Morphology is all you have. Here's one of these little cryptomonads or something like that. Some sort of little nanoflagellate. We were zoomed in on it for a second there. Yeah, it could be convergent evolution. That's one way that you could produce that. Maybe they just haven't. There's some suggestion that organisms may evolve genetically as they're separating before they evolve morphologically. And so if you catch them before they've separated morphologically, genetically they may already be distinct. So do I know what the physical differentiator was between Neanderthals and our species? Yes. I think it's the occipital bun, which is this little bump on the back of our head, and the brow ridge, these morphological features that were very distinct. They also have a different body plan than Homo sapiens. So the Neanderthals had a slightly, like a different shape than even anatomically modern humans. But they could interbreed. And so there's evidence of Neanderthal DNA in human DNA, in modern human DNA, suggesting at some point they were still capable of interbreeding somewhat. So is being able to interbreed even transitive, like A can interbreed with B and B can interbreed with C, but yes. That's a really good question, Freeman. There's species of salamanders they call this ring species. There's a group of salamanders that are like this, where they live around the rim of like a giant set of mountains or a volcano. I don't remember what it was. It's something like that. And each of the salamanders can interbreed with the ones that are immediately next to them. And then as you go around the ring to the other side of the rim of this valley where the salamanders are, if you introduced a population from the opposite side of the rim who has no neighbors that it in common with the other side of the rim, they cannot interbreed. But all the ones that are adjacent to them, they can. So that is actually a really, really interesting example of that problem. So they just call those like a ring species, basically, where like everything around the rim can interbreed with each other, but they can't all do it, right? It's only with their most immediate neighbors. So people have found that it's a pretty rare occurrence, but it does happen in nature. Um, I wish I knew off the top of my head what the salamander species are that make up that group, but I'm not actually a geneticist. So I feel like if we had science in here, maybe they would be able to tell us. But that's not really what I do. I'm on the morphological end of this, and morphologically, those salamanders actually have some pretty different characteristics. Look at this spazzy guy. Just zooming around. Alright, let's I'll keep looking a little bit, and you can keep asking questions. We found another rotifer here. This is a Deloid rotifer. But it's a pretty unusual case. So here you can see, like the one that we found in the tube, this is a similar kind of organism. It's on the move, but you can see it's got a little toe with 3 feet, or little foot with 3 toes down there at the bottom, and it's just holding on to the slide itself, the glass slide itself, to help push itself around. Got my Etch-a-Sketch skills a little out of practice, but you can see that's how they sort of get around. They kind of inch around the neighborhood. If I can get it to sit still for just a little bit. Oops, wrong button. I want to put it inside that box. Oh, there's its foot. You can see the 3 little toes. Actually, I think it has 4 toes. There's a Cenodesmus. It's just a little faster than I can keep up with easily. Now it's going in a circle. There, it has a little antenna that's sticking out. We talked about the antenna in the other rotifer. There, it stopped for a second and pulled its corona out, and then zoomed around with it a little bit. There's an example of it, like a little helicopter. They can use that cilia to power themselves in one direction very quickly. And so it's actually one of the things that make the rotifer as a group a little bit more dynamic than most of the other organisms in ponds that are microscopic. Ciliates and rotifers are much faster than most of the other organisms, and so they can just zoom from one place to another. And some of them use that to help capture prey. So it's, in some cases, part of their strategy. Not all of the rotifer are the kind that just sit in place and vacuum stuff up like this guy's doing. Well, sorry, this gal is doing. All of the Deloid rotifer are female. So they only make clones, and depending on what species you're looking at, between 10 million and 75 million years, they've only been female. So they don't produce any males, and that means genetically they are all, there's a few lines, but they are all genetically nearly identical. Hey Esterella, how are you doing? How's your Sunday going? We're looking at some stuff from my pond again. Started a little bit earlier in the day than I have in the past for light microscope streams. Here's a diatom. I think we lost that rotifer. It finally escaped me. It's another diatom. All the diatoms are Gomphanema that we see regularly here. All these are diatoms are all Gomphanemas. This little strand is just covered with Vorticella, I think. Those are little Vorticellas. A bunch of little tiny Vorticellas. Pretty cool. Yay for early streams. Are there any rotifer which have a strong enough grip to stick to fishes? Fish actually have, it's actually an interesting question. Fish actually have a defense against things sticking to them. Aside from just having scales, which obviously fish have scales on the outsides of their bodies, fish also make like a slimy coating. And they do it intentionally to keep things from growing on them and from sticking to them. And that's actually how you can tell, in part, that a fish is healthy. That they're covered with this sort of natural slime that they use to keep things from getting into or onto them. And it's like a protection, it's like a protective slime that they make over their bodies. So, probably not. The only things that usually can stick to fish usually stick in their gills, and they're experts at it. So, there's a little ciliate that's been trapped, and that means we can sneak in and look at it. But there are a lot of things that they can grow on or attach themselves to. Here's our little ciliate. It's like a Strombidium type ciliate. It's got like a ring of cilia around the anterior end, and it's spinning it around, but it's not attached to anything. And it's worked its way out of a little trap that it had stuck itself in, that it had parked itself in. And you can see the little ciliate ring around the top, around the anterior end. And those ones, they're free-floating or swimming, basically. Hey, Cyanophyte, how's it going? I still haven't seen you stream yet, Cyanophyte. I thought you said you were going to start streaming. I'll give you a shout-out. Hopefully you'll start streaming soon. Let's see. Why they're so slippery. My clawless hands weep. Yeah. I don't know what is going on outside of this room, but I feel like I need to go tell my daughter to stop screaming at the top of her lungs. It sounds like she's excited about something. It could be anything. She's 8, so... I'm kind of surprised she hasn't poked herself in here, but she also was running around most of the day with no pants on, so I'm kind of glad she hasn't. She's on spring break, so she's just going to be like a wild animal for part of the day here, I think. Check out this little guy sitting still for us. Look at the little hairs all around the outside of its body. Looks like maybe it's a dinoflagellate of some type. Or a ciliate, a Heliozoan ciliate maybe. You're gonna start soon? Just some unexpected life stuff happened. Okay. I'll let you know on Discord when you start. Okay, cool. Also, I gave a shout out to Estorella, who was here for a little bit. Maybe she's still here. But if you like digital art and like to watch people draw stuff and sometimes tell cool stories about what they're drawing, you should check out Estrella. She usually streams on Tuesdays in the afternoon, and I usually find a way to drop into her streams between my classes. So, highly recommend that you check her out. She does this great artwork, and she also drew a picture of my daughter. This is an example of some of her artwork that gets floating up there, and also a picture of Sylvia that popped up that she drew. So, digitally drew. Live on Twitch. So, very cool. I watch a lot of art streams and music streams on Twitch when I'm not in science rooms checking out people's science streams. That is another rotifer. So on its back end here, on the posterior end, you can see it's got little feet that are hooked onto the glass, and a mastax. If you look very carefully while it's moving around, you can see in between the outer part that's its head, there's like a chomping going on in the middle inside its body. And it's holding on with its feet and chomping up bits of things all around it. So this is a little predator version of a rotifer that goes looking for its food. It doesn't usually stay in place. It'll attach itself very briefly, and then it'll just go whirring around in the slide through the water looking for more places to eat stuff. So, but that is a rotifer. A different type, but still a rotifer. Even.pro. Hello, Even. Or Evan. How can it stick to the glass but not to scales? Well, again, the scales are slippery because they've got like a slimy coating on them. And I think if the fish just had their scales, there would be a lot of organisms that could attach to the fish scales. So if you look at turtles, for example, they don't have a slimy coating. And turtles actually get stuff growing on them, including algae that grow and attach. They've got a whole colony, like a whole community living on their shells. And same thing I think is true for things like crayfish and actually a lot of the larger mammals as well. So manatees, dolphins, and whales all have stuff that grow attached to them because they don't make that slimy coating. And there's groups of diatoms that basically live in that that live in those types of environments. Scientists watched art streams. Yes, I mostly watch music streams and art streams, but I'm also sort of an artsy scientist. So because I do some art, but I don't draw on Twitch. So I do drawings. So you want to draw, but the sites you use are closed. I do draw using CorelDRAW. Mostly I do a different style of drawing, though. I mostly sort of reshape things using the shape modifying tools. So I start with a shape and then I reshape it, put it in the back, and stack things up. A different style than people actually like with skill, that draw things that have a lot of skill. I have a pretty different approach to drawing or rendering things. There's a little Vorticella and a diatom together. The artist inside me is choking the scientist inside me. Hey, Numb the Geek. Speaking of musicians that I love to watch, there's Numb the Geek. Look at this. I don't think I've ever even got to use my Numb command in this channel, because he just usually lurks in here rather than chatting. When we see Numb the Geek, he's just lurking around like this in the chat instead of chatting with us. Thanks for dropping in, Numb. Numb's one of my favorite musicians to watch on Twitch, and if you're not following him and you sit around in my channel enough, you'll probably get stuck in a raid where we go visit him. So this is a Vorticella. So you can tell this because it's got this little spring-loaded stem, and then it's got a bell-shaped body with little cilia that are spinning on the sides over here. And it's what's causing all the particles to move. It's rapidly spinning, sort of wiggling the cilia on the margins all the way around the top of it, and it's causing all these particles to basically create a vortex, which is where they get their name, Vorticella. So just like that. We were looking at a spider under a crappy USB microscope today, but I usually do software development. Oh, that's cool. I have a pretty nice let's see, if I had started streaming about 10 minutes sooner, you would have raided with 16 degenerates that would have loved this stuff. Oh, that's okay. Tom Thinks is a great, that's a great substitute. You'll get to me one of these days. I actually love watching Tom Thinks draw stuff. So I'm sure they're very happy and they're watching, what's his name, eat Doritos or whatever. You know, degenerates probably, if they're degenerates, they probably like to feed two-dimensional blobs Doritos. Who doesn't? But I sometimes look at spiders in the scanning electron microscope or stereo microscope. They don't fit in a light microscope like this one very well because they're not translucent. Most of the things that live in the water are translucent, so it's a little bit easier to look at them like this. And USB microscopes can be pretty good. Oops, there goes a little guy. I didn't even know what that was. It went through so fast. There's another one. I can't. Oh, that's like a Rogostoma or something. The really little round guys. The other thing that thing that went flying through. I don't know what that is. It's too small, and it's all of its living parts are blocking my field of view. I'm used to identifying most things in a death state because I look at fossils mostly. So a lot of the streams, there's a couple of rotifers. If you can see both of them at the same time. There they are. Those are rotifers. They've attached by the foot end. Most of the things I look at are dead though, so they're not so hard to keep up with. Yeah, Borb, that's his name. Yeah, they do sort of teleport, so. Hey, Unmagical Me, hello. also here visiting. We've got a lot of people in here. Oh, I see. The microscope you're using belongs to Cozy Chickens. I didn't know she was in here. I just texted her your link. Oh, cool. Uh, so I will give a shout out to, I don't know what Even does, but you said you usually do development, software development.
Good news, everyone.
We'll see what your About Me says. You build tools, games, and bots, and more for yourself and for other Twitch streamers. Well, that's cool. Very neat. And I don't think I've ever seen one of your streams, but if you're using a microscope, I will check it out. And Cozy Chickens, also a streamer, I'm assuming? Do you just stream chickens? Oh, yes. Oh, it's well lit. It's a well lit chicken coop in there. I see. This is very cool. You brought all your friends with you. And you all know Devil and Mrs. J, so that's nice. I'll give her a shout out as well. He programmed a chicken feeder. Oh, okay. You guys know, let's see. What's the guy who builds the chicken coops sometimes and also has his own chickens? He also plays like games with his fans. I'm trying to think of what his name is. Axel? Is that his name? Axel? I think my subscription to him just disappeared recently, so... he does something similar to that anyway. I don't know about programming chicken feeders, but he does sort of 3D printing and stuff as well. Your bot powers Cozy Chicken streams, and Marked Up Cyborg uses your TTS and stream a game that you coded and stuff. Oh, this is very cool. I like it when you've got your own like tight community of streamers. I have a similar sort of combination with a bunch of microscope streamers. But there's another type of rotifer right here. If you really like microscope streams, I have this big long list of people who use microscopes to stream. And like you, we work together sometimes. So Pacific Plankton and I are close friends, and she sends me stuff occasionally. And OpenSet is another, he's like a music streamer who also does microscope stuff. You may know him already. Spider Gary D uses a stereo microscope to look at spiders. And Dell Maximum is up there as well. Dell and Pacific and I have been friends for a really long time here. And then Freckled Science is on like every night, so you should probably know her. Fizzaria is mostly a musician, but she sometimes pulls out a microscope and does some microscope streaming. And then our friend Studio Cornix is also here in this list. You should check her out. She does art using a microscope. And Michael Learning, who was here when we started, uses a microscope to look at mushrooms. Jolkson is on pretty regularly. He doesn't talk a lot. His stream's mostly just a little bit of music. And then the sort of thing that we're looking at here. And then Volcano Doc sometimes uses her microscope to look at minerals, which is pretty cool. I want to do a geology stream one of these days. I keep threatening to do it, but I haven't figured out how to hook up any of the camera stuff to the petrographic scopes. And science streams I think is on right now. They're doing art, or they were when I first started. And they have also been exchanging ants with me, and I've been sending them diatoms, and we've been sort of bouncing back and forth between me looking at ants and not knowing what I'm talking about, and him looking at diatoms and not knowing what he's talking about. So it's a nice combination to be able to share sort of materials with our communities together. And like I said, a lot of the microscope streamers, we all know each other pretty well. And also Cyanophyte, give Cyanophyte a follow too. You have a cool idea for creative streams, microscope sculpting. You mean like using a microscope to sculpt something, like up close? Yeah, OpenSet's one of our favorites as well. I haven't seen OpenSet on in a really long time. He's elusive. He just streams whenever he wants to, which means a lot of times he does just like keyboard streams, and he shows up at like 1 in the morning and starts streaming something. He used to be on all the time when I first started, and he used to hang out in here a lot as well, but I think he's just been busy with work. So he's a math tutor in his spare time, but he just does mostly keyboards and microscope stuff and sort of psychedelic, trippy visual stuff during his streams. I don't have a lot of trippy stuff. I do have some pretty cool rewards, like you can make me bounce around on the screen like this. It's about as close as I can get to being trippy. Now I'm upside down, me bouncing around on the stream, and that's about as close as I get to trippy. You can also like change the color of my little globe. Like, oh no! I thought it was going to get me for a second there. It was coming right at my face. And that's about it for trippy, I guess. We don't have any super cool, fun stuff like mirrored cameras and that stuff. Yeah, the rotifer came right at my face. I'm pretty sure it was going to get me if I wasn't in this. Oh, it's coming again. Yeah. This is just using the Orin board to bounce me around, and so you can newt if you want to use a water bear to shout out things. And I do have this one cool thing, which is instead of watching my face, you can watch Mustachio talk in my place. So I'll just convert myself into Mustachio, who normally sits in the corner. And I'll just put the mask on for a little bit here so you can see what happens. This is an example of Mustachio doing my voice, and a little bit of psychedelic puppetry on my part. So if you're wondering, hey, what is that little green thing that's down in the corner? It's one of my emotes. That's Mustachio. And right now I have become Mustachio. And if I can shake off this mask, you can go back to seeing me, but it requires me to do a little bit of a, I have to kind of really shake myself up a bit. So let's see if I just like it like this, and then it'll pop off and go back into the corner, so it'll be fine. That's about as trippy as we get around here. The frame didn't turn green. I was playing with all the colors, so oh, you redeemed googly eyes. Broken symmetry, hello. I probably screwed it up because I was clicking through all the colors when we were doing things, and I changed it to purple there at the end. So I switch it back to green for you, Sorella. Let's see. We do have googly eyes. Let me see if I can find something to put googly eyes on. I don't know. This guy isn't moving very much. Maybe we could try. Ooh. Okay, let's see. With googly eyes, let's see. We put the googly eyes on. This little guy, we'll just see if we can manage to get him to stay still long enough for the googly eyes. There we go. And then you can just type googly, like googly. Oh, why didn't that work? Google. There we go. And then it's supposed to work, isn't it? You type googly. Well, it's not working right now. Let me see. We'll just do a little troubleshooting. We'll fix it. Googly. Yeah, I don't know. It should work. It's acting weird. Oh well. I can Google it from here. I'll just spin him around. Unfortunately, this little guy moves a bit too fast for me to keep the eyes on him. Look at this. It's like I can get one eye on and then... Let's try to find something that's not moving so much and we'll put the googly eyes on it. Yeah? Let's go. Let's go back to this, let's see, I think it was somewhere in here. When we started, we found this, I found this really cool... Oh, there's a worm. It's a really big worm. It's a flatworm. There's one end of it, it's just poking into the water bubble there. Somewhere down here. That's a ciliate. There's a little ciliate, it's not moving very much. There we go. Have I ever scanned chocolate? Alright, now got him there, and we'll Google. You get the Google. Perfect. He looks like a scrubbing bubble. He looks exactly like little scrubbing bubbles. Oh, there he goes. If you like it, put an eye on it. Exactly. Okay. Hopefully get your money out of that. I wonder if I could build a version of this that does motion tracking that keeps an eye on it. Well, that's a challenge. Give it a shot. Have I ever scanned chocolate? Do you mean like in the scanning electron microscope, Estrella? No. I've never tried putting chocolate in the scanning electron microscope, but we did look at it. We did look at candy corn once. Oh, you know what? These things don't move at all. This little Cenodesmus would be great. We'll zoom in on it. There, it's not going anywhere. They just sit there. I don't know that chocolate would look that good in an SEM, but maybe. We put a mustache on this guy. We'll just give him a little mustache. I really need to work on... It's more like maybe 40? Yeah, okay. Put that there. And we'll put some googly eyes on him. Like there. There we go. See, now he's not going anywhere. And we don't have to use any fancy tracking. He's got a mustache. He's got his eyes all googled. Perfect. And look how happy he looks. A feather we have put in the scanning electron microscope, Cozy Chickens, but not a chicken feather. We looked at a blue jay feather once, and I'm trying to think of what other feathers. I think maybe a robin feather once, because I have a bird feeder. Sometimes I just stream my bird feeder in my backyard, and I just found a feather that fell off of something in both cases, and then we brought it in and put it in the SEM. So we've definitely looked at those in the scanning electron microscope before. If you click on the link for the Instagram for the SEM page, you'll see some of my art and photography there. So that's here, and if you click on that link and just scroll down, you'll see a whole bunch of things. We've looked at mosquito wings, we've looked at spiders, we've looked at all kinds of diatoms, of course. Those streams usually happen on Wednesday afternoons, when I have time, which is most weeks. I usually set aside a little bit of time to look at some stuff in the SEM, and we've looked at a bunch of stuff. Here's an example of one of the feathers that we looked at. He looks like someone you know. Oh, cool. That's a blue jay feather, and those little blobs you see sitting in it are actually pieces of pollen. And there's all kinds of stuff in there. We've looked at pollen. Here's another, if you really like feathers, there's another image of feathers. And another one. I've colorized all of these. In the SEM they're actually just black and white. But there's some examples for you of feathers in the SEM. Evan can do literally anything. Well, I would be happy to see him try. You'll add it to your list. Okay. It would be really neat to have the mustache and the googly eyes just automatically move whenever things move. People would freak out. They already like the mustache and googly eye combinations. I get a lot of people who really like that part where we just stick anthropomorphic eye features on. Let me see if I can find this tube rotifer that I had at the beginning of the stream. And then if I can't, oh, there's this tube. I think that's the tube right there. It's I think it's basically run out of steam. It's hiding in there. One of the things that happens when you ooh, that's super bright, sorry about that. One of the things that happens when you have a cover slip on is that the pressure starts to build up, and it can be actually really intense. And the only way to really relieve that is for me to take the cover slip off. So if I want to save this poor little rotifer, probably need to take the cover slip off, and I'll just rinse it into this little dish I have that's next to me here. It's like a piece of it that doesn't want to leave the slide. And we'll just, we'll make another one. I want to make sure that I don't accidentally kill what we're looking at, if I can help it. Sometimes you just can't help it. You end up killing stuff. Most of the things that we look at are clones, or they replicate from pretty quickly from encysted eggs. So, but that doesn't mean I want to kill them. I'd like to try to keep them alive, especially if it's something rare. Then we can see it again next time. If I put it back in the pond, hopefully it will live. So, oh, what's this? we have a little worm. That's a flatworm. I think you can see that. Yeah. It's stuck under a bunch of debris, but... Okay, I'm super far behind. Hi, Digital Seahorse. How you been? Seahorse. Like that. Thanks for dropping in. If it moves as you move the cursor, oh, maybe. We've had a bunch of really cool streamers in here tonight, as usual. I think my streams actually draw more streamers than other types of people. So there's a whole bunch of people I've shouted out, and if I, for some reason, forgot you, please don't take it personally. I'm trying to like juggle a microscope, conversation, and a stream all at once. There was a worm back there. We'll come back and look at it if I don't find anything else that's super interesting. I might actually just try zooming in on some of the Vorticella here as well. Those are all diatoms growing on that right there. You could scan a cookie, then drop a cookie on the floor near the front door, and then scan it again. Why would I want to scan a cookie from the floor? What's my purpose in cookie scanning? So we could see what how long we have to leave something on the ground before you shouldn't eat it. Because I think if I dropped a cookie and you put it in the SEM, you probably would never eat a dropped piece of food again in your life. I think probably you would realize that there's a lot of stuff you can't see that lands on a cookie, and it's better off going in the trash. I think that's where you would probably be if I showed you something and you dropped on the floor, and then in the scanning electron microscope before and after. I feel like you would go, oh yeah, I'm done eating stuff off the floor. I mean, your body probably won't be hurt by it, but if you knew what it looked like, you probably would be grossed out. So, I'm just going to lay that out there. You probably don't want to see that. What's going on here? Oh. Oh, it's a, another worm. A different kind of worm. It's a nematode worm. Right there, that's a little nematode. There's a Vorticella. Here's that big flatworm we were looking at before. Still stuck underneath a bunch of junk. 5-second rule. Today, debunking the 5-second rule, fact or fiction. Yeah. 5 things people don't want you to see when you pick up a cookie off the floor, and then like click this link if you'd like to watch that. So if you eat these bacteria, will you get sick? Cozy chickens, you probably would not. Most of the things that are in here are so small, your body would just digest them. You probably wouldn't get sick from any of it, but I don't recommend that you drink pond water. There is some things in the pond water that can make you sick. It's usually Giardia, which is like a type of bacteria that's lives in the bodies of snails and is parasitic on them. And I don't think you want that. That will make you very sick. So if you're drinking pond water on purpose, it's probably a bad idea. I don't recommend it, but I think your body would be fine. You just might, you might have some adverse effects. Most of these little guys, though, they aren't going to hurt anything. Most of the things that we're looking at are either ciliates, which are the things that have little tiny hairs around their body that use them to move around. Rotifer, which are harmless for the most part. Little worms, most of which probably would not harm you. and like a nematode's not going to hurt you, like that little guy right there. He's just wiggling around. But you'd kill them. Your body would kill them for sure. They don't do very well in acid situations, and your stomach's acid would probably digest them. But some of the bacteria are dangerous for people, and so I just don't, I wouldn't recommend drinking it. Drink water that's been filtered, or that's not to say if you're swimming in a pond and you splash some water in your mouth that it would kill you. It probably wouldn't. Usually you have to consume a lot of it to get enough of it to really create a serious problem for you. But I don't recommend it. Filter your water before you drink it if you're out in nature, unless you don't have any choice. And then if you have a choice, but you're desperate, you have no choice and you're desperate, drink flowing water would be my recommendation, because it's stagnant water where most of the things that are really dangerous will get you in some serious trouble with respect to your body. So if for some reason you're desperate, you're out of water, you're trapped out in nature, and you're thinking, I don't have any choice, I've got to drink something, find a stream and drink from a flowing water stream, and pick one that smells good, or doesn't smell bad at least. Stagnant water is usually a bad place to drink from. So my pond is actually partially flowing. I've got a fountain on one end of it. I still wouldn't drink from it though. I think my body would be fine. I don't think my body would get hurt, but I just don't think it's a great plan. Here's a little Vorticella. You can see they live on a stalk. They have a bell-shaped body. They can retract their little bell-shaped body. And you can see up at the top they have these little tiny hairs. So they're a ciliate. You can see the little hairs, they fold them out from inside. They basically pull them, when it contracts, it pulls them in. And then when it stretches itself back out to full size, it pops them back out and starts spinning them. And it's creating that little gyre in the water. So it's well under 5 seconds. Sorry. You just had a birthday stream earlier this weekend, Drawful 2, and one of the devs took notice and joined in the game. Oh, that's awesome. Cool story, Seahorse. Here, I'm going to try to get this cilia in focus for us a little bit. So this organism is Vorticella. We've been looking at these. Vorticella. A little bit all night, so how do we end up on the topic of really gross things? I don't know. I blame Esterella and broken symmetry. So one of your dogs had Giardia, yeah, and it was really bad. Yeah, it's not the thing you want. You're imagining a butter sample slide from the butter side down toast drop. Yeah, we could do that if you want. I just don't think you're going to like it. You're better off not knowing what's on your floor. How come our hairs don't help move us around? Well, if you could figure out how to wiggle them, Esterella, they would. Mostly our hairs act as friction, I think. But if I could figure out how to make my beard hair wiggle and then food just comes into my mouth as a result, I would do that. And I could just sit there and wiggle my beard hair. There's enough of it. It could be effective as a means to consume things. Just I have to figure out how to get into a media that's thick enough that it'll actually create a vortex. So what if we moved faster with hairy legs? I don't know. Changamania, hello. How are you doing? We're talking about gross stuff that you find in a microscope, or you could find in a microscope. Welcome in. Just Chang. Pretty sure that one works. There we go. If you don't know Cheng, he's a friend of our channel here on Twitch. He's a science-based streamer. Does woodworking, does some sort of really cool stuff with a ham radio, and repairs pianos, sometimes on stream. So you should check out Chenkmania. One of my favorite streams to watch because we both do woodworking sometimes. Even though right now I'm looking at wiggly things in the microscope. A lot of times on my stream we're looking at stuff in the scanning electron microscope. I still do some woodworking streams. The last thing I made in my wood shop was a shaker, a musical shaker. So like a little square wooden box that you can fill with stuff and then right? But so pretty simple. And then I made it with like a little wooden knob you could screw on and off, and then you can fill it with different things. So if you wanted to just put chickpeas or rice or something in there. And then I sent it to a streamer, Asymmetrical Soul, who streams here on Twitch, as a gift for playing music for me. So if you're not following Asymmetrical Soul, you should check him out. Also, I think I have a command for him. It's just Ginger, because he's a ginger. Are any of the potential dangerous things that could be in a pond water things that you'd be able to visually identify with this microscope? Probably not. I don't know that I can see or identify bacteria very easily, and I am not a person who studies bacteria. You can see bacteria in a microscope. In fact, if I moved us around, you could probably see some little spiral-shaped organisms that are sort of wiggling through the water, or if you look in the background of these images, you'll see some of these very small things, like this little thing. That's probably bacteria. They're pretty small. Not very identifiable, I think, at this scale. So, have I ever looked at feces? No. Mainly not interested in looking at feces, but, you know, if, I mean, there's some in our field of view right now. It's just that it's like the feces of microorganisms, right? So I guess incidentally we see feces, but not like human feces, no, or bird feces, or any sort of animal feces. Not really my thing, because one, it is unlikely to be exciting. You know, only chocolate. Not even chocolate, just candy corn. We've looked at raisins before. Oh my god, I've been looking for one of these all night. I found one. This is one of my favorite microorganisms. That is a little tiny Lacrymaria, I think. It's either recently lost its head, or it's just a little one. They're sometimes called, their common name is swan's tears, so they look like a little teardrop. And they can completely lose their heads, and then they'll just regrow them. And what they normally do, this one looks like it has a really big body and a really small head, but their heads usually just zip around looking into things for them, and they stretch them out like giraffes almost. You can see it's a ciliate. If you look carefully at its head, which is the skinny part up here, you'll see that there's a whole bunch of little tiny hairs that are spinning around really fast. Yeah, I'm pretty sure that's Lacrymaria. It's not doing its normal behavior, which is usually it parks itself somewhere, and then it just sends its head out to go do things, like on its neck, and it can stretch itself really, really far It stretches its head and neck like super, super far out. And it doesn't detach, but it can have its head bitten off completely and it will just regrow its head. And maybe that's happened relatively recently to it because it doesn't have a very long neck. Um, it doesn't have their normal, like, super long neck that they grow. It could also be that when it's swimming like this, it just hasn't extended it. Um, but they can totally regrow their heads. And they're predators, so they'll stop like this. They'll park themselves someplace. Look how full it is. Look how much stuff it has in its belly. It's just like chunky, and yeah, they're really super cool to watch. They're one of my favorite little organisms. They'll just park themselves someplace, and then they'll just, like, their head will just come like zinging out on a long neck and go chasing after things. It's cool. Yes, it might be. It might be looking for a place to park itself, and if it does, that would be super cool. There's another organism that's kind of similar shape to it, which I sometimes confuse it with, but I think that's a Lacromeria. If it can find some place to park itself, it'll probably just park itself there, and then it'll start doing throwing its neck around. So, Junkers McGee. Is it really a head, or no? It's its mouth is on it. It's its head, and it can actually completely get removed, and it will regrow, which is kind of cool. Like I said, there's another organism that's kind of similar, but I think it usually has like a mouth in the sort of neck area for those, and this one actually has the same head as the one that I'm used to seeing as Lacromeria, so that's what it is. What a cool little guy. Just swimming around, belly full of food. I don't know how long it takes to regrow the head, Evan. I've never seen one lose their head, but I have seen them like parked and just like their whole body is tucked away inside something, and you just see their head come whipping around looking for food on its neck. It's super cool to watch. Do I ever look at the lemon rind from bars? No. I mean, we could look at a lemon rind. Why does it have to be from a bar? Cozy Chicken. Can't we just look at a lemon rind from my kitchen? You can see it's stretching out a little bit right there. Maybe it's looking for some place to hide. It's okay. I'm still amazed that its head can grow back. Yeah, yeah, yeah. That's like it's like a safe way of living, right? To just go ahead and send your head out, go look for food on a long neck. We found a bunch of stuff. Last time when I was streaming, I think it was maybe 2 weeks ago from my pond, like from material from my pond, we found some Stentors. And I also was hoping we'd find some today, but I haven't seen any Stentors. I haven't seen a lot of this sort of same swimming, like, ciliates that we saw last time either. But in the time where I've been streaming, we've seen a bunch of different stuff, and I made a couple of slides, and each slide had sort of like some things that were the same and some things that were unique. So I found a fair amount of, like, in the, just in the differences in the slides that I made. I made them all from the same material, but sometimes I saw some different things in each slide. So sometimes we had these nematode worms like you're seeing here. It's a big long nematode worm. And the flatworm that we saw earlier, those were pretty common in the samples that had a lot of material, like a lot of vegetative material. This green stuff that you see in the foreground that's not moving is mostly Cladophora and diatoms. And then these little bell-shaped things that we're seeing everywhere are Vorticella. Oh, anonymous cheerer cheered 1 bit. Thank you for the penny. This is Vorticella right here. These are nematode. This is a nematode worm. That's like the front end of it. And then it spirals all the way through the scene, basically. It's got a really long body. It's all the way down here. It's the tail end of it. And then here's another nematode nested in that little bit. Is this guy still out here swimming around? But we didn't see any of those Lacrymaria in any of the other samples. We did see Vorticella everywhere. Still see a bunch of Vorticella here. And before I started streaming, I actually found some coleps, and I found some paramecium-like organisms. I haven't seen any of that stuff. So if I just keep making slides, I'll probably just keep finding things. The way that I collected this sample was a little earlier in the day. I just went out with this bowl, and it has these sort of square sides to it, which maybe you can't see very well unless I tilt it upward. And I just scraped the bowl up the side of my koi pond, the sort of tarp that protects the water from leaking out of the pond. And there's a bunch of Cladophora that's growing there on the sides. So, and then I brought it inside and tried to warm it up so that we would get it a little bit warmer, so that the ciliates and things would basically hatch if there were any in the water that were in eggs. So you can now VIP people. Excellent. Cool. Well, oops, there's a little tiny version of that worm. Look at the little tiny worm. It's a flatworm, I think. You can see it's got these little pairs of hairs and segments on its body. That is a tiny worm. Recently either split from the rest of the organism, either voluntarily or involuntarily, and the rest of the organism is missing, or maybe just hatched from an egg relatively recently. You have to lurk. You have a meeting in a few minutes. A meeting on a Sunday? That's rude. Thanks for dropping in, Chingmania. It kind of looks like a tardigrade. It isn't. It's definitely a worm, but if you want to see a tardigrade, I could try to mix this up some. How many of these critters are floating around your tap water? None of them. Graphical user interface, unless your tap water is coming from a very weird source. City water is treated, so it shouldn't be in city water. And most of these organisms either photosynthesize or eat things that photosynthesize as their primary food source. So of the things that we're looking at here, none of them should be in your water. Generally speaking, this is not something. If you took a piece of some of your tap water and put it in a microscope, what you'd find is that it's super boring. There's nothing in it. It's rude, and you'd love to change it. Yeah. Oh yeah, shape. Yeah, shape-wise, it does look a little bit because it's short, stocky body. There you can see the cilia very clearly. Wiggling around. Even well water should be less living than this. Yeah, well water can have some stuff in it. Probably it runs through a charcoal filter or something before it gets to your glasses, like something that you drink out of. So probably you wouldn't see any of that stuff in it. At our house, we have reverse osmosis purified ice cubes and drinking water. So there's nothing at all in ours. So, do I have a culture of tardigrades growing somewhere? Not inside my house, but they're on the sticks everywhere in my yard. Every stick that I've ever picked up from my yard has water bears living on it, and in the lichen. And so, like, I have a culture of them growing outside. I could access pretty easily. Um, you know, it would probably take like 10 minutes of stream time for me to go get a stick and scrape it and prep it. And then I don't know how long before the water bears would start moving. Usually it's another 5 or 10 minutes before they rehydrate enough that they will start crawling around. Um, but, we could do it. I've done it in streams before. I started with streams where I just had the stick and scraped some of it into a bowl and added water. But usually I do that before we start because I want to make sure that there's something in it. But I could just pretty much guarantee it if it's in my yard or my driveway or on my roof that it probably has water bears and rotifers and nematode worms. Those things are always present. I've never not had them in any of those things. So, can be gained. Sometimes we look at water bears in my night streams. There's some cool stuff that lives on sticks that will just rehydrate. Among them, rotifers, the bedelloid rotifers that we've seen in this stream living in water will also occur living in just on sticks. And water bears, and there's that little worm. Sometimes we'll find diatoms, sometimes mites. You'll find mites living on sticks. And testate amoeba are pretty common. So, do I have some 10 to 20 minutes of prepared footage? No. I have somewhere I think I have a e-bike trip that I took that's like 10 minutes long. I don't know that people want to watch that though. What time is it? I don't know how long I've been streaming. Only about 2 hours. I can leave some stuff on here just wiggling around and go grab a stick if you guys are interested. Oh yeah, drop in puns. Okay, I can get a stick. Hang on, I'm gonna zoom you in on the worm. And then you can watch it wiggle around for a bit. I'm sure I have some sticks that are easily accessible. And I'll just wander off. And here's I'll put my little mask back on so you can't see into my room while I'm trying to go get sticks. This way, if my 8-year-old daughter wanders in with her with no pants on, I won't get in trouble from Twitch. Be back in a minute. Alright, so, haven't lost everybody. I'll pop this little mask off so you can see the sticks that I collected. These are from my driveway and my yard. That's a little bit of lichen on the stick right there. So the glowing green stuff is just some lichen. And this one's got a little bit of a fungus on it as well, but I'm trying to avoid that part. And just grab the part with the lichen on it, and here's another one. Again, you can see the surface is covered with a little bit of lichen. I tried when I first started looking for water bears to look in mosses and all kinds of things, all kinds of places, and I found that the easiest way to find them was sticks. So I'm gonna lower this camera down just a little bit. So you can see what I'm up to. This is just a paring knife, and it's dull. And the sticks that we looked at, and a bowl. That's it. And I'm just rubbing the sharp end of the stick along the lichen to fragment it into the bowl. And you're now involved in an ASMR stick rubbing stream, for which I apologize, but you didn't have to pay extra for it, so at least there's that. And then, so just basically scraping the lichen off in small enough chunks that we could ensure that I can fit it onto a slide, which is the only part that's a challenge. So there's still actually quite a bit on there, and I don't ever get all of the lichen off. I just sort of scrape some of it. And I usually try to avoid scraping the bark off. That's why I'm just running the blade across the lichen. And that's only because the bark, there actually might be some stuff living in the bark, but it's pretty opaque, and as a result doesn't show up very well in the light microscope, which we're looking through things to see. And then I've got lichen all over my desk, but I'm taking out some of these big chunks. And then this is what you're left with, is just basically some of the powdered version of that lichen at the bottom. Yeah, there's a giant worm in the bottom of the bowl. And then I'm going to take some of the water from my pond, and I'm just going to put some of it in here. Normally I use the RoPure water from my drinking water tap for doing this, instead of using the tap water, because tap water is sometimes chlorinated, and the chlorine kills things. So in order to avoid killing things, I can just use the pond water, and I'm just stirring it a little bit into the lichen, which is mostly floating, to try to get it a little bit wetter. And then that's it. So usually it just has to sit for a little bit for the organisms to hydrate. And I usually use a slightly, I have these little pipettes, and I usually clip them so that they have a little bit wider opening associated with the end of them. I don't think this knife will actually cut through it because it's really dull. but I'm going to get some scissors and I'm just going to chop that a little bit so I can make some slides. So again, I'll be back in a second. And just cut the tip of that pipette off so I can put some of this material on a slide. And then I don't usually use a cover slip for samples where I'm looking for water bears, largely because I want to put as much of the stuff on here as possible and try to get as much of it on the slide. So you can see that the pipette has like a little bit of the lichen in it, and it's settling through. And then I'm just gonna dump that onto the slide and sort of spread it out a little bit with the water. Yeah, broken symmetry. They're too small to get crushed for the most part, and also they're in a dehydrated state. Like the water bears, people fixate on water bears because they're extremophiles, and one of the things that they're capable of withstanding when they're in their dehydrated state is really high pressure. So they aren't really negatively affected too much by me scraping over them. So one, they're too small. Probably the most important part is that they're too small. And then secondly, they are dried out. So they're probably not in a state where they could be easily crushed. So there's a little bit of current as it's like draining off one side of my slide a little bit here, and that's because the desktop is just slightly tilted. I guess because your arms rest more comfortably on it that way, but the microscope is then as a result slightly tilted. So sometimes when I go looking through slides like this, I'll just find some things that I think might be water bears, and I can't tell until they hydrate enough that they start moving around, because they literally, yeah, they just look like this basically when they're, oops, that's slightly off the screen still. Yeah, that's a water bear, I think. Oh no, it's a rotifer? I think it's a rotifer that's coming, it's rehydrating. I guess we'll just have to wait and see. It's usually 5 minutes or less before some of them start moving around. Like this thing started, you saw it was dry when we put it in. That's the foot or the toes of a rotifer right there. And it's basically just coming to life. So, less than a minute, the rotifers are already basically trying to, and there's some stuff that's already come to life in the water. These are the Deloid rotifers. They basically can get dehydrated like this and then can come right back to life. So people are mostly fixated on water bears, but do you see how quickly this thing just is like went from completely dry state to wriggling around, right? So that's this is a Deloid rotifer, and it's already crawling. It did not take long at all. So sometimes I just find these little pink things that are, on the stage like this, and I'm not sure whether it's a water bear or a rotifer until it starts to unpack, basically. That one is definitely a rotifer though. And it's already looking for food. It's already basically reached the point where it went looking for food. So it does not take long. And I've found some water bears before, and I would be like, oh, I think it's a water bear, and I will start the stream, and before I can even get the stream completely going, like it's still sort of loading, the water bears will already be out and moving, because I thought, oh, it'd be kind of cool to just hydrate one like on stream so people could see how quickly they hydrate. But it's kind of hard to find them, and then when you find them, it's like they're usually already hydrated and moving by the time the stream starts. So, and you can see there's a lot of debris. Probably another thing that I noticed when I first started doing this, looking for water bears, was a lot of times it's hard to find them. They're not everywhere in the material. They're pretty uncommon, and so it might actually take a while of zooming around before you can spot one, even in the best of circumstances. It looks like maybe it's a mite. I'm not sure. Those look like little legs. So, yeah, wake up, eat, and then go right back to sleep when you're done. That's pretty much how they rule. They just hydrate. They're around long enough to maybe eat, lay some eggs, and then dehydrate again. There's definitely some people who've got water bears, in labs that they go through testing how many cycles, like wet and dry cycles, they live, and I think most water bears only have like an active lifespan of less than a year, but they can be in their deactivated states for up to 10 years. So, I mean, it's kind of hard to figure out how long they live as a result, because, they're in this system where they basically just reactivate and then, the dormant state can be the most of their life, in terms of total length of time. So, it's going to take some looking. That's the other thing. So it's usually like a bit of a hunt. So when we go looking for water bears like this, it's usually like I usually don't see them in the first slide that I make, and I think it's because they just haven't activated yet. So it usually takes 2 slides before I start to see them. The other thing is you'll sometimes just see particles moving. Like if I'm not moving the slide, some of the lichen will be moving, so all that debris you're seeing is just pieces of lichen and maybe a little bark thrown in. Sometimes you'll just see it moving around. That's because I'm moving the stage and it wiggles around as a result. And other times I'm not moving the stage and it's still moving, and then I use that as like a clue to help me find things. That's a rotifer that's waking up. That is a rotifer that is already awake. You can see how much more productive the rotifers usually are. They usually make up, like, of the things that I run into when I'm looking through lichen, I would say most of the things I run into are rotifers. Water bears are present in these environments. They're just not abundant. And so I think the other problem is I used to just stop looking because I didn't find them in the first slide that I made. And so you just have to be a little bit more patient. This pink thing that's here in the middle that's round, I think it's a rotifer, but usually this sort of like pink fleshy colored stuff, it can go either way. It'll unfold itself from that little ball. If it's a water bear, we'll start to see the legs. And they have 8 legs, so that's a clue. And each of their legs has sets of claws on the ends of them, so that's the other clue. And if we find one, that's usually how I can tell pretty quickly. We just count the number of legs, and rotifers only have 1 foot. It does have claws on the end of it, but it's just one. So 1 set of claws, and their bodies look pretty different, like in terms of total shape. So I've sent sticks that were full of lichen to people before and said, there's definitely water bears in here, and then they never find them. But I think it's just a matter of being patient and scanning over the whole slide and knowing that you're looking for these little pink balls that are activating. See, that's moving around on its own. This little pink thing in the middle. Yeah, I've never seen them in moss. I know that's their nickname, but I never see them in mosses. This thing is unfolding, and it's moving around on its own. Just a little. So there's something there waking up, and I'm not sure if that's a water bear or a rotifer. These are the 2 most likely suspects. Oh, it looks like it's ruptured. Looks like it's hemorrhaging out goo from its insides. That's not a good sign. Whatever that was, it's not going to make it. It either got caught in something when I was rubbing the knife over it, or maybe it was already ruptured when it died. That is a water bear. There you go. It's magical. We got one. It didn't take long at all. There you go. Told you we would find one. We always find one on sticks. Here's the claw on one of its feet. That's a definite giveaway that you're looking at a water bear. The little claws on the ends of its feet. See how it flexes them? And it's still waking up, so it's confused. But you can see it flexing the little claws. What are they eating? It may be eating some of the lichen. I think it can consume the lichen when it's wet. But that is for sure a water bear. It's just basically uncoiling itself still. It doesn't have all of its feet popped out yet. The ones in the back for a water bear are like scallop legs. They're like bound together, and they usually use them to hook onto stuff, and then the ones in the front, they move independently. So its head is on this side. You can see the claws are all pointed backward, and its back 2 legs are back here. It hasn't fully extended them yet. They're still kind of clumped there together. And then 1, 2, 3, 4. It gets like 4 of their legs are sort of out. It's really still coming to life. You can see it's still like trying to stretch itself into its body. There it goes. Now its head's popped out. There's its face. It has a little... Yep. There it goes. The face has got like a little newt snout on the front of it. Is the 0.2 millimeters, or is it because of magnification? Let's see. We're looking at 10x, so it's actually bigger, not smaller. Hang on. Let me fix this. This should be this one. So its size is Let me see if I can move this. Maybe 0.3 millimeters in terms of its total length. Yeah, it got a big stretch going, and then it really started to, now you can see it's basically got its whole body out, and the front legs are going, and its back legs are stuck on something, and its face has these little tiny, like it's got a snout, and then its little face has these little tiny like tentacle like spines on the nose piece for this particular species. And you can see that really clearly right there for a second. So I can try to keep its head in focus, but there's its head, and that thing right there is its little snout, and there's its little front legs, and it's caught up in a bunch of debris, so it's just trying to like unwind itself from it. Usually they attach themselves to something a little bit bigger. And some water bear species have eyes, and some of them don't have eyes at all. So it's hard to say whether, from what we've seen, whether it is one of the species with eyes. Sometimes when they have eyes, they're on little stalks. So, but we went from no water bears and sticks. You know, if you were here for that part, we just did it all live on screen. Everything on stream, from sticks with lichen, a little bit of water, and within 5 minutes, here you have water bear crawling around. So you can, you know, if you know what you're looking for, and you know, you have a microscope that, this is on the lowest magnification my microscope has, by the way. So this is 10x magnification, and oh, you know what's going on? It's trying to molt. That's what's going on. That's why it's having such a hard time. Its back legs are coming out of the casing. It's actually molting. You see the skin that it's growing out of is still wrapped around its back legs. This is all of its skin. It's coming off. Its exoskeleton's coming off, and they do that before they grow, because they're, you know, like all the crustacean arthropods, basically, they have like a hard skeleton, and it limits their size. And you can see the casing back here, the clear part with nothing in it, right? And its front legs are just pulling really hard, trying to get the casing to come off of its back legs. That's why it's like coiled around. It's like what its back legs are stuck in. It's stuck in its own casing back there. So it's trying to molt out of the back leg casings, and that's why it's struggling so hard right now. So it's because there's a part of it, which I think you can, oh wait, you can see it, I hope. It's like the clear part of the casing back here. Its body's not in it anymore, right? It's just hanging out back there, and it's just struggling with getting that piece of the casing off of its body right here. You see that? That's how I could tell, because it's like clearly pulling its legs out from this. Yeah, right? It's like, I just want to get my legs out. It's like, you know, you've been in a sleeping bag before, right? One of those tight-fitting sleeping bags, and basically it's just trying to like get the legs out from the sleeping bag. It's the situation that it's in right now. This is a big water bear, by the way. They can range in size to like a quarter as big as this. Regularly see them a lot smaller than this one, like maybe half this size. But it's this species. This species is actually quite large, and so you know, I think probably there's 3 or 4 species that I've seen regularly around Indiana, which is where I live, and depending on what kind of things I sample. Why won't Clips let you name this? I don't know. You should be able to name stuff. Let's give our little water bear a newt newt. There we go. That's like our welcome noise for the water bear. Welcome into the world as you shed your skin. There you can definitely see the bottom part of its leg casings. The loose part of its leg casing right there, and then its legs are just wrapped in it, and it's slowly kicking it off and slowly pulling itself out of the casing that it's in. It's pretty cool. I don't know that I've ever seen one of these like on screen before, on stream before. I think I've seen it before, but I don't know that I've ever seen it happening actually while I was streaming. Say, look at water bears occasionally just for educational, like, funsies, and sometimes I just want to look around and see where I can find, like, I'll go to the park for some reason, recreational purposes or something, and I'll see some sticks and I'll just grab them just to see what we can find in it. So it was too long by a millisecond. But this is pretty cool, and it was actually pretty neat to be able to show everybody how easy it was to find. You probably won't get this lucky if you tried this at home and you had a microscope at home, but really we're looking at this at about so it's on the 10x objective, and my camera is zoomed in 3 times the normal size, which is actually like 5 times the normal size because I have it 2 times. Oh no, I take the magnifier off. This is like 300 times magnification. So if you're looking for like how close we are, right here we're about 100 times, or more like 70 times magnification. And when we zoom in, we're like, I don't know, it says 300, but it's actually probably closer to like 250, because it's the camera's got a adapter between it that clips part of the magnification. So, hey, tealfish, welcome in. We're looking at some water bears, and if you don't know Tealfish Studio, they are half of a team of streamers, and I regularly watch Rosemary, who's a musician. So welcome in. I'll give you a little taste of your own high medicine right there. We're right now just looking at this water bear as it's molting, and it's shedding this back part of its skin. It's trying to work its way out. So, and earlier I was looking at some materials from the pond in the back of my yard. So I have a koi pond. It's actually just got goldfish in it because the hawks or herons or something keeps eating my koi, and they're too expensive for me to replace constantly. So it's like $25 to start with a little tiny koi, and then it gets to full size, and then something eats it. Could also be raccoons. There are a lot of raccoons in the neighborhood, but I don't know that they would be able to catch it. So I haven't set up any sort of a camera to watch what happens. Could also be one of my neighbors. I don't know. You never know. But I think Teal mostly does the graphic stuff. I was watching their stream a little bit earlier, and they were struggling with a looper, and I think maybe Rosemary had let Tealfish Studio play with the looper. It wasn't going super well. She was yelling at him a lot. So, in a fun way. Anyhow, welcome in. You gotta set up a new channel just for the quick one. Well, I do stream, as you know, on weekends. A lot of times I'll just do the birds in my backyard, and the koi pond is there. But I don't want to do like a 24-hour stream. I just want to be able to It was a lot of fun. Your loops were pretty cool. I had it on in the background while I was playing Valheim, and and then I think somebody else that I was listening to started streaming, so I only listened to it for a little while. It looks like it's mostly gotten its its exoskeleton off, though. You can see the whole water bear's previous skeleton is sitting right there. Are they rare to find? No. We just found one live on stream. I mean, like, I went out and I got these sticks before you were, I think before you came into the channel. And from, like, somebody said, hey, do you have any water bears? And I said, I can go get some. And hi, Rosemary. And I said, I'll just go get some sticks from my driveway. And so, like, I just wandered out into my yard. My neighbors are probably like, oh, there's some guy roaming around the neighbor's yard again with his, like, cell phone flashlight trying to collect sticks for some reason. And so I went out and got some sticks, and we scraped the sticks here. Everybody was watching me do it, and then I added a little bit of water to the sample and put it right on a slide, and here you go. So we went from sticks with lichen to this little cutie in, I think maybe we found him in under 10 minutes. So I underestimated how quickly we could find one. And there he is. And he was molting, or she, I don't know whether it's a boy or a girl, but it was molting when we found it, and now it's completely molted, and it's ready to grow into its new exoskeleton, which probably hasn't completely hardened just yet. We also ran into some rotifers while we were looking around, so that had also basically come back to life in a very short little window, like even less than the 5 minutes that it took this thing to detach itself. So it was pretty cool. It's pretty nice to showcase. And if I hadn't looked before at the sticks in my yard, I probably would not be so confident as to say we definitely would find one. But every stick, every time I scrape the lichen off of them from my yard, I always find them. So, and I usually take this lichen part that I hydrated and I throw it back out into the yard, and I also throw the sticks back out into the yard to try to minimize the potential harm of, for the water bears. So, and whatever else is living on that in that ecosystem. So I have a pile of sticks right outside the door of my house that have all had the lichen scraped off of them, and then a pile of lichen that probably gets dumped out there right next to it. But I didn't take from those. I collected these 2 sticks from the driveway and one stick from the oak tree in the front yard, which almost always has something living on it. So, and I just stuck all the lichen together in one sample, like. You wish you could see if you had some there. Well, you can. I mean, I guess you need a microscope, but I suppose you could always send me a stick if you'd like, or find somebody who has a microscope. You don't need a very good microscope to see water bears. I have it literally on the lowest magnification. So, and just any old cheap microscope, even like an old used one, would allow you to see water bears. People make mistakes when they buy microscopes. They think, oh, higher magnification is better. And that is true if you're looking at diatoms. If you're looking at something really small, there's value to that. But in these sort of, this is a microscopic organism. You couldn't see it very well with your naked eye, but you don't need to have a high resolution, super high powerful microscope. You can, yeah. Well, so OpenSet's microscope digital. Oh, there's a rotifer just butting in. Hello, hello. Can we help you? Is there some? Can we help you? Just make yourself at home, dude. This is actually a lady. That is a Deloid rotifer as I mentioned, the Deltoid rotifers have gone about 75 million years without sexual reproduction. They just reproduce asexually. And this is a Deltoid rotifer. They're known for, like water bears, they're known for being able to be dehydrated and rehydrated. And they're also extremophiles like water bears. People all know about water bears, but the rotifers are actually a little bit more interesting in a lot of ways. Water bears are mostly sexual organisms, so they reproduce sexually, and they lay eggs inside their casing, and when they molt, usually the females, when they molt, will leave eggs behind that the males will fertilize in the casing, which is kind of gross, but not all. That's just like some species, some genera of water bears, that's how they operate. But the rotifers have also lived a really long time without sexual reproduction at all, just complete asexual reproduction. The ladies, they're all ladies. There's no males whatsoever in the Deltoid rotifers. Like they just don't make males, and they lay eggs. They don't need to be fertilized. They're just clones, and the clones hatch into ladies. So lady, 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 lady for 75 million years, and it's really uncommon in larger organisms, in multicellular organisms, to have complete asexual reproduction. Usually when that happens to an organism, they die. They die out, they go extinct. And that's because there's no progression in their genetic code when you only can make clones of yourself, and that's all you can do, right? So if you can only make clones, then if something happens and you can't adapt to it, then basically that's that's the end of your species. What's interesting about the Deltoid rotifers is that they have this really powerful genetic repair system, that they can basically recover their DNA even if it gets damaged by sun or by mutation, and it's allowed them to sort of maintain themselves even though they've had asexual reproduction. And it's actually like all of the extremophiles, the polyextremophiles like water bears and rotifers, and they all have a similar characteristic, which is that they can be dried out, and that ability to be dried out and be rehydrated and come back to life, which occurs in the water bears and in the rotifers, seems to be linked together with being able to repair damage from radiation, from acid, from high temperature, from low temperature. And so basically it allows them to be these polyextremophiles that can handle a wide range of really crazy conditions. So it's kind of a neat field. It's not my research field. Obviously I study diatoms, but this is I'm interested in extreme environments because diatoms also can be dried out and can come back to life, and they are also a type of extremophile, just not the ones people usually think about. Do the hatchlings eat the molt? No, they just use this as a protection, Cotton. They're like, the casing is a place for them to like hide out, so that they're not exposed as much to everything that's in the environment. And oops, there's that rotifer again, I think. Just butting in. Follow the rotifer a little bit. You can see they sort of inch along. They have just the one claw in the back leg, and then their mouth in the top part. Yes, so they did send some water bears into space because they knew they were extremophiles, and they sent some up with some of the International Space Station, and they had them outside in a vacuum for 10 minutes or so, and they could live in those conditions, but they're not in this state when they're in outer space or they're exposed to the vacuum. They're in their dehydrated state. So before we started, where they were on the stick, that state is actually highly resistant to all kinds of damage, and they have put them into outer space associated with that, and they were wearing little spacesuits. Ours just molted out of it, but When they're in this state, when they're in their hydrated state, they're actually vulnerable. And if you smashed one of them, it would kill them. If you put it in high temperature, it would kill them. If you put them in pH, really low pH, really high pH, it would kill them. So people are confusing, their dehydrated state with their hydrated state, and they think of them as these super resistant organisms, but they're really more like they're really good at hibernating. Essentially, it's not really hibernation because they don't have like they don't shut down their heart organs and stuff like that. So we were talking about this a little bit earlier, Rosemary. It's hard to gauge how long they live because every time it rains, they come back to life, and then when they dry out, when it's not raining. So like the one that's in front of us here that I found on the stick, you know, when it rains or snows, the stick is wet, and they may be active for hours, and then the stick will dry out, and their environment dries out, and then basically they go back to sleep. And they can be in that dormant stage in their tune states for years or up to a decade at least. And if they're hydrated again, they'll come back to life. So, I mean, how do you gauge how long they live when they live in these little punctuated, like they're active and awake for a few hours or maybe, so like if you added all of it up, they maybe only live like a year total at most. But if you think about like how long they're around, they're probably around a couple of decades, but they're only living for like, a part of that. So it's sort of an interesting model for the organisms, in that sense where it's hard to gauge. There's a lot of really confusing issues with microscopic organisms, like if somebody said how long does a diatom live, I usually say, well, I'm not sure what you mean, because it clones itself, and it clones itself like an amoeba does, where like it starts with one organism and then you have two organisms and then you don't know which one is the parent because they're both daughters. So like amoeba are infinite, like they just keep replicating, and as long as they keep making something they started, part of its original amoeba is all the way down the line in every daughter that it ever makes. So like how long does an amoeba live? I mean, like it's hard. It sort of defies our concepts of age, right? Because we think of ourselves as these discrete organisms, but many of the microorganisms, they live by cloning themselves. So like, how long does a clone live? You could probably answer. Hey, science, how's it going? We're looking at some water bears live on the microscope right now. Earlier, we were looking at some pond samples from my backyard. I just was trying to like make up for the fact that I haven't streamed for a little bit. I thought about doing a bird stream this afternoon and also yesterday morning, but it's the same birds I saw last week, so I'm waiting for the migration to come through, and then we should get some really cool birds. I see all of the birds that come through all the really most famous places that migrate. They all come right through my yard. So my sister goes to like McGee Marsh, which is this really famous place where all the warblers come through. She gets all these great pictures, and then I'm like, here's the same bird you got these pictures of, and it's in my backyard, and I didn't have to go anywhere, and I just had to open my window and take pictures out the back window. So I'm waiting anxiously for that to start to happen. Yeah, he can't quite reach. I think part of the thing that makes water bears cute to people is that they are so helpless. They're like little babies, they're like a little baby is when it can't figure out what's going on around it. So I feel like I've gone through some election cycles like that, Sam, by the way, where I just hibernated more or less. How long does a diatom live? Yes. The same thing is true for sponges and amoeba, and I mean, there's just a lot of organisms. It's like they just kind of keep living, and we don't really have a good sense of how they operate. So water bears are pretty cool. Earlier, people were asking me some questions about genetic stuff, and I was like, I don't know. we need science in here because I don't do the genetic side of things. I do the ecology side of things more than anything, and paleoecology most. So he might be up against the glass slide, except for I don't have a top on this one. Cotton, there's no cover slip. I just have the open glass slide on the bottom. So yeah, jellyfish. Actually, jellyfish are really cool. Their jellyfish will reverse their aging process. They can go from their juvenile state to their adult state, and then some of them, there's one that's called immortal jellyfish. It actually can go back to its juvenile state. It can revert to the juvenile state and then go back to the adult state and just bounce back and forth between them. It may be actually drying out a little bit, and I can fix that by putting a little, because I didn't put a cover slip on it. I can actually put some water in. Yeah, I think they look so helpless. Everybody's like, oh, look how cute this helpless little thing it can't see, and it's crawling around. Yeah, so it doesn't, there's no cover slip. And I usually do that on purpose when I put stuff from lichen in here, because the lichen is very lumpy, and if I put a cover slip on it, it'd be a bunch of air bubbles. So I just leave it without a cover slip. So play God and make it rain. Well, I did make it rain when I added the water. So I actually took some of my pond water and put it in the lichen. But the water part, I didn't bring any of the, or I brought probably some of the littlest organisms over, like these little guys that are swimming around in here. Like, that's the water bear. There's some of those Rogostoma and some of these little tiny things. Those are probably from the pond. Most of them. This is the water bear. And we saw some rotifers. Those are probably from the lichen, not from my pond as well. So we're zoomed way out. I'm gonna just bounce this in again. So the night streams, when I usually try to do stuff from the light microscope, are fun for me. But it's like people are a little more excited about animals that are crawling around, I think, than even though the SEM is probably more spectacular visually. The organisms are all, covered in gold and not moving at that point, but we can look a lot closer at them. But I can't do it for a water bear unless it kills them. So we have looked at a water bear in the SEM before. The way I did it is I found a dead one, or maybe it was just a molt of one, but I think it was actually a dead one, because it wasn't moving and it was fully, like its bodies it was fully hydrated and not moving at all. And because I didn't put a cover slip on, I could actually just take it off of there and put it directly onto a stub. So if I had a cover slip, it would just make it impossible for me to actually get it onto the SEM. So that's the other reason I don't put the cover slip on for these samples. One, I don't think the cover slip would be very effective. Two, I don't need to get very close because I'm looking at it at 10x. So the cover slip's usually only helpful if I'm looking at something at 20, 40, or 100x, which is actually 200, 400, 1,000 times magnification. So I generally don't need a cover slip. So, well, we've been staring at this one water bear, like, I don't know, for 45 minutes or something. Maybe I can move around a little bit and we can come back to it. If we can't find any other ones, I'll just mark where we are. We're on the bottom left corner. Hey, Studio, how are you doing? Welcome in. I gave you a shout out earlier, but I'll give you another one right here. Did you go out today to collect samples? Is that what you were doing, Studio? Could there be organisms on the water bear? If so, what would they be? Bacteria probably are present on the water bear, but nothing else is probably living on it. Virus and bacteria. But I have this marked, and let's go exploring, because we did not cover the whole slide, and then I just added a bunch more water to it. And I'm sure that there's some other things in here. We've mostly been looking at the water bear, and we saw some rotifers crawl through. There's a rotifer right there, dragging behind some stuff. And some of the little things are probably from my pond, because I used pond water. But I suspect we might be able to find mites if I look around. There's some bit from the pond water right there. There's some diatoms. There's another rotifer. Or it could be the same one. There's a different rotifer. Little tiny guy. For some reason there's some Cenodesmus from my pond. When I use a microscope for science, when I'm analyzing stuff scientifically, I always go left to right, or right to left across this slide. And for some reason, when I'm showing people things on Twitch, I always go up and down. And I don't know why I would switch that for when I'm streaming. It seems very unusual for me to change, like totally change direction. But that's just what happens. Okay, we'll start here, and we need to go this way. Rotifer. Everything is also backwards and upside down in a microscope, so it's a bit challenging sometimes to figure out which direction you're supposed to be going. Your instincts are all wrong, and then you have to kind of train yourself to go against your instincts. So that's another rotifer. I think we had this sort of ratio. We had one water bear and like a whole bunch of rotifers. In what was here. And then, of course, while I'm looking in the microscope, I can't see what you're typing, so feel free to send questions into chat, and then I'll just try to catch them when I come out. This little thing we saw earlier in the stream, just a little round, hi Hugin, Hugin, what are the really, really small white things swimming around? Bacteria, probably. That is either a rotifer or a water bear in assisted state. They dried and they never hydrated, or they haven't hydrated yet. This like ball, it could unpack itself at any time, but it's either going to be a water bear or a rotifer. It's like my daughter has these Hatchimals, like it's a little egg, and then you open it, and then you get to see what's in it, and it's a surprise. It's like that. It'll be a total surprise to us. Whichever way it goes, we'll never know until it unfolds. But they both have that sort of like rounded, eggy shape to them. The really, really tiny stuff, yeah, are probably just bacteria. So, two things. One, I'm looking to see if there's any other organisms in the lichen, and I'm expecting that we would see some nematode worms. And here we are. There's a nematode worm. This is their normal behavior. Also very cute. They look like they're always look like they're at a rave. They're dancing to some music that we can't hear. Here we go. And it looks like they've got the entire constellation inside their body. Very pretty very simple organisms that are everywhere. And whatever they're doing, they're having a lot more fun than we are. I'm sure of that. Because they are always like this. Like, there's always a dance song going on. They're vibing for sure. This is their mode. When they're active, this is the way they look. And Schrodinger's water bear, yeah, exactly. Water fur, exactly. What organisms are alive in the average sample of tap water in the U.S.? Nothing, really. Bacteria, maybe, if you're unlucky. But I would say most tap water has nothing in it at all. It's extremely boring. You're not going to find it in tap water unless it's growing in your sink itself, probably. If you want to find samples like this is from a stick. So you're not going to see any of these things. This is lichen. Nematodes are probably present in your sink somewhere, but, watch out for snakes. Skunts. A skunt? What is a skunt? It's having a grand old time. One of the things that surprised me about nematodes is, besides the fact that they're everywhere, like you find this thing was on a stick, right, is that they seem super strong. Like, look at all the stuff they can knock around, like with just by wiggling around. Oh! I see. It was a music song. I see. Well, we can get Rosemary and her husband to play us some of the looping music they were playing earlier, and we'll see what the worm does. We could use this as inspiration, right? Because it's definitely got some sort of a beat going on. They work out. Yeah, they've definitely got, like, but it's like they've got a lot of muscle. Like, when you see them, they just knock everything. Like, they can just move all of the lichen around. Like, they're strong. And it's crazy. Like, they're super simple organisms, and it's amazing to me how strong they are. Just like everything just being knocked out of the way. Like, they're like, I'm having my day. Everyone get out. Abs of steel. How do you tell the head from the tail? I don't know. I think if you look closely, the head has a slightly different shape than the tail. They're swole. I also think that you can tell from the movement that the head is this end, right? Because the movement initiates here, and then the rest of the body follows it. And if it's like anything else, that's usually the head end. So the anterior end is probably controlling the situation. That's how I would identify it, but I am not a nematode expert. But it seems to me like that's probably the case, that the back end of it seems to be following the front end of it. So you could use its relative motion to tell you. Yeah, it's tapered a little bit. It moves by doing crunches. Exactly. They eat a lot more than the rest of the animals of its size. I don't think so, Conceit. I don't think they I don't know. I think they're just mostly muscle. I think that's how they manage it. They're mostly just like really simple muscles, and I mean, they're just buff. I don't know what to tell you. But they seem really strong, and they're flexing. So they got a show. They got a gun show, and they brought their guns. So we need a nematode jam emote. Yeah. Well, I've got an extra animated. I should probably think about something with it. That would be funny. Even Grunge Bro. Yeah. So, hard to say. The strong little snakes. Yeah. I actually think they're really cute for being worms. They are highly entertaining to me. And normally I can hear what music is playing because it's just pretzel rock, right? But I can't stand to hear myself talking as an echo after I talk, so I mute what you guys are listening to. And my headphones don't have any music or anything in them right now. They're just covering my ears. I don't know why. But I started off listening to it to make sure the music was there, and now I just feel like I have to put my headphones back on. Sometimes I'm listening to different music than you guys, though. They're cute until they drink your pineapple house. Is that what happened? I don't have a pineapple house, so I think I'm safe. All right, let's keep looking. We can always come back and look at the nematode worms. I just want to see if there's anything else present. I have seen mites before, like actually mites, in samples of lichen. That is a rotifer from my pond. That is not from this sample. That is a mite, actually right there. I didn't stage this, but that's a dead mite. It's not living. It's not moving. It may actually just be a molt of a mite. But that is a mite. That's what they look like. Little hairy things. If it were alive, it'd be crawling around. So, wearing your headphones so no one will talk to you. No one's talking to me anyway, it's fine. There's a rotifer. That one's from this sample, not from my pond, I think. That is why I've got the noise cancelling headphones, because I've got an 8-year-old, and she's usually louder than I want on some level. Okay. Let's keep looking. And then I want to come back and take a look at our water bear friend one more time before there's another nematode. This one's actually under the lichen, but watch how it just moves everything around. It doesn't care. It's just like, and here's another one. You just see stuff on the stage will just be wiggling like crazy, and it's like, oh, there's a nematode. This one looks like it got injured. See? Like the back end of it, it's not working right. It might have got scraped when that's from my pond. It might have gotten scraped when I scraped the stick. And for that I apologize a little bit. Mr. Nematode. I think that's a rotifer. There's two things on the screen, and I'm trying to figure out what the top one is.
Good news, everyone!
There's a bunch of little things up here. That is a rotifer sticking its face out right there, crawling. I don't think you need an explanation, besides I have an 8-year-old. Exactly. Do you find them mostly in still or moving water? Hugh, I don't know which thing you mean. This I found on sticks, so it wasn't even in water when we started. Where did the little things that were crawling around? There were some little things crawling around on this lichen. Looked like maybe they were little tiny, either mites or little tiny water bears. Maybe they just recently hatched. Something we could potentially run into. You know, because we've had it on stage here for about an hour. And I suppose it's feasible that we could run into hatched water bears in that time. We did see the one that we were looking at was molting. So anything could happen. That is a nematode. But I heard my cat. So yeah, everything that we're looking at here just started off as a piece of a stick, a piece of lichen on a stick that I scraped off with a knife. There's another nematode. And these rotifers, the water bears, and the nematodes are common organisms that I find on sticks with lichen, basically anywhere I've looked. And that includes like materials from random sticks from parks and like sticks that I've taken off the roof of my house or off my garage or my driveway or my front yard. It doesn't matter. But I haven't found any in moss at all. And if you're looking for water bears, that's the way I would recommend that you look for them. Just go get yourself a stick and a paring knife and a little bowl, and make sure it has a lot of lichen on it and that it falls off the tree on its own. So it's like an old stick with like a lot of lichen on it. Hey, guess what, guys? Remember that I was telling you that the water bear lay their eggs inside the molt of the females will lay them inside the molt? That is the molt of a water bear. You can see the little claws. There's the claws. This is the molt of a water bear, and these are water bear eggs. These are all little water bear eggs. They're the tiny, we got a tiny little water bear farm. Right here. I know that for sure, because that are the back claws of the water bear, and this is its molt. That's its exoskeleton. Remember the one we saw when we first started was molting. It was obviously doing something similar to this. They're my responsibility now because I found them. I could keep the slide. When we first started streaming from the microscopes at home, my daughter wanted to give it a try, and so she went into the yard and she collected sticks, and then I helped her scrape them into a bowl, and we had a little tiny microscope, and I had my microscope and she had a little tiny microscope, and somehow I'm a dad again. This time I'm a water bear dad. So she looked around in her slide while I was looking around in my slide, and she actually found water bears. And so she was very excited because she went from like, you know, like you would be if you were here and we were doing this sort of thing and you found the water bear. So she was super excited because she's just a little kid. But she did all of it herself. She collected the sticks. I think I helped her scrape it, and that was the only part that I had any part in. She actually made the slides herself. And then we saved that slide. It's still somewhere here in the house with the water bear dried onto it. And she had chat name that, it looks like a bag of grapes, yeah. She had the chat name the water bear, and we named it Goo-Boo. And so I had this artwork that I drew at some point that I put on, I don't think I have it in my OBS right now, but I had it on, it's on the Redbubble site for my channel as a sticker, and there's a little sign, he's got a little badge that says like Goo-Boo lives, because we kept the actual like slide that it was on and somewhere here in the house if you wanted to look for Goo-Boo. We had Goo-Boo the water bear, and we had little like yeah. So Devil and Mrs. J was here. And he has a little pin that says like Goo-Boo lives on his pin. So it's pretty funny. But here it is. So this is Yes, in XU we're looking at the molt of a water bear. Sorry if you're coming in late and you don't know what I'm looking at. It's not a bag of grapes. It is, this is the molt of a water bear. You can see the claws on the ends of its little molted legs here. And its outline, and its head was up here. It came out of the sleeping bag on this end, and as it was crawling out it laid eggs, and these are the water bear eggs. So we actually found not just the living water bear earlier, but a set of water bear eggs. And there we go. I gotta put these in, and I'm not going to count all the eggs. I'm just going to count this as one water bear, but we've seen 12 water bears since I started counting. Which I don't know, it's been many more than that, but I just added the commands at some point. But I'm very excited about this. We have found eggs like this before. This isn't the first time I've seen them, but just because we collected this sample on stream, like the whole thing, like I disappeared for a minute and came back with sticks from my yard and then scraped them, and so like this is the first slide that we made from it, and it's been highly productive. So we found cool water bear eggs. We found an actual water bear crawling around. And I'm going to mark where we are. We're like 2/3 away top right. And I can come back to that, and I guess I'll have to curate this slide since how everybody's made it my responsibility to take care of the water bear eggs now. But that was pretty cool. It's pretty neat to be able to just grab a stick and then, you know, this is one of the nice things about having a microscope at home. A nice high-powered microscope is there's always content, right? This was easy for us to dig up a sample, and I'll probably try to do another microscope stream later this week, but from someplace else. There's something moving in here. I'm not sure what that is, but there's a whole bunch of stuff moving, so I'm going to guess it's a nematode worm. Hang on. That's a water bear. Here we go. And we're on the other side of this slide, so this is not the one that we saw earlier. What's the gestation period of the eggs? I don't know. So many pieces of content. Yeah, in a drop of water, exactly. So I'm going to add one more water bear sighting. Oops, not noon. Newt. And we'll give a little newt newt for our water bear that we found. Very nice. And we'll zoom in and take a look at her. Here we go. It's the same species as the other one that we saw. It's got the same size. It's large. It has a reddish cast to it, and it also has the around the trunk or the proboscis of it. It has these little tiny, like mole-like fingerling-like things sticking out in the front end. And actually, this one has eyes. So these little bumps that you can see right here sticking off of them, there's like little tiny pieces sticking off. Those are eye stalks. It's got little eyes that are sticking out right here. Here's one. Can barely keep up with it, and there's one on the other side that matches it, but they're coming out like here from the cheeks, not from the proboscis part. So it's drifting on this little material that it found. And who knows, maybe it's the mama that goes along with those eggs that we saw. You know, it wasn't that far from here, so it could totally be. It could be the mama for that sack of grapes we saw earlier. It's pretty cool. So, what's the gestation period? I don't know. Some water bears, we talked about this, was a little kind of gross, but some of the water bears actually lay the eggs unfertilized, and then the male comes along, finds them in the casing, and fertilizes them after the female's completely gone from the site. And then other ones give basically like nearly live birth. So there's like a really wide range in terms of the water bears, and I'm not an expert, and I don't know their I don't know the gestation period, like how long we would have to sit and watch this in order for those things to start moving. And it may be that they wouldn't because they haven't been fertilized, or maybe they have been. I don't know. Hard to say. So, yeah, it's a pretty weird behavior, but there's a really wide range of habitats. Hey, Miss Daisy D! Look, we're looking at a water bear. Earlier we saw, I'm sure you'll be happy to hear this, we found a water bear molt with all the little eggs in it. If you're not following Miss Daisy D, you should. She's one of my favorite streamers, and she does drawings. She plays a little D&D. There's a nematode. There's a nematode worm trying to like photobomb up here. It's like, what about me, guys? What about, remember how cool I was a bit ago? I'm still around. And this one is completely detached from all stuff, so it's waiting to try to find a thing. He's trying really hard. You know, he's got eyes, so he ought to be able to find it. But you should check out Miss Daisy D. She does some ceramic pins, she does some, like, all kinds of cool art stuff. And she's been streaming a little bit more recently, so. Did we just find 4 water bears? No. We found 2 living and 1 molt. And the first one that we saw was molting, like as we were seeing it. So I'm only counting that as 1. And I didn't count the molt as 1. So we've seen 2, technically, in this batch from the beginning. But that little guy's now behind a bunch of junk, so I'm gonna go looking around for something else. There's some more nematodes over here, some crazy nematode action. Also, this side of the slide is now starting to dry out a little bit. Uh-oh, what's this? Rotifer, nematode, and nematode. And you can see there's sort of like a rainbow halo around all of the lichen. That is a rotifer right there. I'm wondering if it's going to fold out. Nope. I thought maybe it was going to fold out its little corona for us. But it's just squirming around. It wants to pretend it's floating around the vastness of space, yeah. Yes. How does it breathe? Most organisms that are this small breathe directly through their skin. So cuticular respiration is normally the way that most, like arthropods and things that are this small, insects in general, and things that belong in the arthropods, mostly just breathe right through their skin. So there's diffused, dissolved oxygen in the water, and they just breathe the oxygen straight through their skin. Some of them have gills, especially some of the aquatic insects have gills, but I think in the case of water bears, they just have cuticular respiration. In other words, they just breathe through their skin. They're small enough that basically that's a strategy that will work okay. And the same thing is true for... There's something crawling around in here. I think it's a tiny rotifer. Yeah, tiny rotifer. But that's a good question. So, you know, they need oxygen, like all animals. There's a rotifer. That looks like it's no more. There's a nematode, spazzing out as usual. And another one, spazzing out as usual. That is another mite right there. That red case is just a can you teach him trick? I don't think so. That is the exoskeleton for a mite. And sorry, I'm not sure what this is, but I think it's a water bear. Give me a second. I see little claws. Or I think I see little claws. Yeah, that's a water bear. So this one's covered in a bunch of goo. Maybe it's trying to molt like the first one we saw, but see the little tiny claws here? And I saw some more up here on the head end. This is its, I think it's its back end. You can see it has little tiny claws, like little tiny hook, like really nasty looking hooked claws. So there's your third one, if we're not counting the babies. That's another water bear. I'm usually not very diligent about marking those. You have new babies in your fish tank. Turns out the dance battles my fish were doing were mating dances. You'd figured that much, but the fryer's starting to hatch. That's awesome. Yeah, we've done pretty good on catching water bears in the sample, right, Rosemary? Like, this is 3 plus the babies. So, I mean, if we don't count the babies, we have 3 living water bears. Lots of nematodes. There's another spazzing nematode. It's probably starting to get mad because it's drying up on this side of the slide. I mean, that is part of their life strategy, though, is to dry out. There's a whole bunch of nematodes on this end. There's a whole bunch. I don't know what's going on. This whole end of the slide is all covered with nematodes. There's another one. There's another one. But it's starting to dry out a little bit over here. Here's another one. It's got also big clumps of lichen everywhere because when I added water, I was trying to keep it away from the water bear we had on the other end. And it pushed all of the lichen down to this end, and it must have pushed a bunch of the nematodes down to this end when it did. That's why I think probably they're all down here. There's a whole bunch of them, though. Like, basically one every field of view that I have, I see a nematode in it, or a dead nematode. Okay, all these rainbow halos were at the edge of the slide. So let's go back and look at the first. That's another nematode. Let's go back and look at the, let's see, the babies were like somewhere in here. That's a rotifer. There they are. Hey, I did pretty good at guessing that. Just marked it with my eyes. There's the little eggs. So this is, we found a molt. You can tell it's a water bear because you can see the claws down here and also up here, the little claws on the back end. Hey, how's it going, Ham? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There's 16 little water bear baby eggs right there. The females will molt and then they'll lay the eggs in the molt casing. And you can see the little claws for the water bear claws up here. But that's the molt. There's actually a really good view of the water bear's claws. You see those really clearly right there. And their little tiny sleeping bag bodies. So the babies are inside tardigrades. Sometimes the females will have the babies in their body, and then when they molt, you know, it's like I was saying in the early part of the slide, we found a water bear that was molting, and it just shed the skin. It didn't lay eggs when it went, so maybe it was a male, or maybe it just didn't have any eggs in the chamber. But they will molt and then lay the eggs as they're wiggling their way out of the molt so that it protects the babies. Yeah, the tauntaun, they're babies. Yeah, you missed the part where I was talking about this, Miss Daisy D, but sometimes they come out unfertilized and then the male water bears will find the eggs and fertilize them in the molt. So it depends on the species, but it's even weirder than tauntauning their babies on some level. They just sort of lay the eggs out there. So that's the we found that though. That was pretty cool. And then I'm going to zoom over to the other end of this slide where we originally found a water bear. Apologies for the crazy movement. And see if this one is still around someplace where we can find it. When this slide starts to dry up a bit, oh, that's a rotifer. Oh, it's got an egg. There's a little rotifer with an egg. Let me see if we can zoom in enough and you can see that. Yeah, in its body, right there. Right here. There's an egg in that rotifer. It's a big rotifer, but I think that's an egg. I think this one's going to lay an egg. Yeah, in the husk. Yeah, it's pretty interesting and disgusting. A great comic. The rotifers, this is a Deloid rotifer, which means it's a female. They're all female, and they clone themselves. I don't know if they only lay one egg, or if this one may have already laid eggs, but that egg doesn't need to be fertilized. It's just a clone. It's just a straight clone of the mother. So, they just give birth to themselves, basically. Pretty interesting. The Deloid rotifers are like this, as I mentioned, for the last, 75 million years. In some species it's 10 million years, in some it's 75 million years, but all of the Deloid rotifers are female. That are in this group that look this way. They're all female, and they're all lay eggs that are just clones of themselves. So it only needs to lay one, but I suppose if it wants the population to grow, it's going to have to lay at least two, right? But just make more of themselves. Anyways, what I was saying is, when the slide starts to dry out, the rotifers and the water bears will also start to dry out, but they actually, oh, there's our water bear from before. This is the one that we saw first. This is the one that molted when we first saw it. It's down here in this corner. But they can actually move a lot more because their natural environment is not like sloppy lichen on a glass slide, but rather rigid lichen that's mounted on a stick. And so this behavior is actually a little bit closer to the way they normally get around in their environment. They're a little less helpless when it's not quite as wet, right? Because then the lichen is stuck and they can crawl and sort of scramble over them a little bit more easily. What happened to all the males? They became unnecessary. They just decided they didn't need them anymore, and that was the end of it. Once they found a way to lay eggs that would make clones without having to fertilize them, then the males become useless and they get done away with. So evolution doesn't care about you anymore at that point. And as what I was saying earlier is one of the things, the future of human males, possibly. Probably not in my lifetime, but I've already got a child, so, and I'm not planning on having any more, so, whatever happens at this point, I don't really care. Do whatever you'd like at this point, ladies. If you can figure out a way to make your own, do it. But the blueprint for that is that they are capable of repairing their damage, so they don't need to worry about evolution as long as they're perfectly adapted to the environment that they live in, and their DNA can be repaired pretty well, right? I've served my purpose, right? I've already got, let's see, my older sister has 4 kids and my younger sister has 1 kid. So each of them have 1/4 of my DNA, and then my kid has 2/4 of my DNA. So I'm 7/4 represented in terms of genetically. So I feel like I've got everything covered. 7/4 means there's at least 1 3/4 of me going to be around after I die. So, yeah, I'm fine. I've served all purposes. Yeah, it's been going on a long time, Peachops. How are you doing, Peachops? Somewhere. I don't remember. It's been so long since I've seen you. I don't remember what the... Is it just Peachops? I don't know. I don't remember what it is. I used to have a command for you. It's been a while. Chops. There you go. Peachops. If you're not following Peachops, he plays really cool music, and he does these really cool visual effects, and it wipes your brain clean. So, you know, if you want to have a nice clean brain, make it presentable, you know. You're okay with your genes not being passed on? Better for everyone. I'm just saying genetically I'm done. I'm not saying it's good or bad. It's just, you know, my DNA's been replicated more than once. 1 3/4 times. So, Miss Daisy D, are you in Colorado right now? Are you hanging out with Susie? Is that what you're doing? Are you secretly away from home? You can see that the water bear is starting to dry up in their little environment. Not yet. Next week. Okay. I wasn't sure because she started cleaning already, so, you know. Or at least she said she had started cleaning already, so. There it is, trying to crawl around. Futilely. But you can see the little eyes on the sides of its head right here. Just coming out like where the cheeks are. There's an extra little piece sticking out, and there's an eye on the end of that stalk. So the back claws are used to grab stuff and hold on to them, and the front claws are used for exploration. Basically, thank you for the follow. I haven't been paying attention. You have 2 nieces. Oh, there you go. You're half represented, Studio. Half your DNA's out there. 36 hours before someone visits. I usually get... my wife usually makes us start cleaning like a week before somebody comes, and then, you know, for the week after they're gone, our house is nice and clean, and then it's a mess again, because 8-year-old, you know. She doesn't care about how clean or dirty the house is. It's a little bit bright, so I was just trying to get my camera to auto white balance. Okay, well, I feel like we've looked all around, and I've been going for a really long time for a microscope stream from the light microscope. We did really cool stuff. We looked at a bunch of really cool things from my pond. Diatoms and rotifers from the water environment, not the Delloid type, although we did also see some of those. We saw a bunch of Vorticella and Alacromeria, I think, and a ton of different types of worms and other kinds of random ciliates that were present. And then somebody said, hey, could you also look at water bears? And I said yes, and there we are. I went outside and got a stick, and I scraped it live on stage right here in front of everybody, and then prepped a slide, and we found water bears and baby water bears and rotifers and really cool vibing nematode worms. Thanks everybody for hanging out, and I think probably we'll call it a night. We got a follow from Solo Stegosaur, from Quinn Thing Trash Queen, what a cool name, from Josh is so dumb, I mean, if you say so, Josh, Marked Up Cyborg, Cozy Chickens, who, if you're not following, maybe you should check out their chickens, and those were our follows. We had an anonymous cheer, and we got some people that played around with the thingies on stream, like changing my colors and bouncing me around, and whatever else we did. We put the little mask on me, so like when I talk, it's actually the little talking diatom guy, and we did all kinds of cool things. We had a pretty successful hunt, and I turned into Mustachio, which I feel like is a good thing. For a while there, we had googly eyes, and generally, I think we had a pretty good time. So thanks everybody for hanging out, and it was a really long 3.5 hour stream for me, which is pretty uncommon, but I started pretty early. So ready to plan to raid, but I had to mute. Okay, well, I don't know who we're going to raid, but thank you everybody for watching, and I'm going to take a look at who's around, and then we'll do a raid. Oh, Lord Spew is doing his dueling draw, so we could potentially go there. I'm trying to think of what else we could do. Digital Seahorse is also on doing Drawful 2. So either of those are options. These are the credits that are rolling by. Tealfish, thanks for dropping in, and Rosemary also. I'm glad you guys were able to drop by, especially because I've seen you guys stream so frequently, especially Rosemary. And it's nice to be able for you guys to at least see who you're dealing with on the other side, I guess. And I thought it was fun that we got some really cool stuff. So, best googly eyes on Twitch. I think that's probably true. I don't know who my competition is, but thanks everybody. And I don't know, where are we going to go? Do we want to go to see Lord Spew? Do we want to go to Corey Clark Live and doing some music? Do we want to see what Digital Seahorse is up to? Anybody out there have a... Oh, you might hop on later. Okay, well, you're going to miss my raid then if you wait, Studio. But maybe I didn't give a shout out to Rosemary. Sorry about that, Rosemary. If you're not following Rosemary Teal and you like music streams, you should definitely give her a follow. She plays all her own music. Occasionally she does some streams that are like requests, whatever, but most of the time it's just her own music, which I think is super brave and cool. She just has enough of her own music that she can just play her own stuff. So you should drop by and give her a listen. She's got a really great guitar sound and plays her own music, so I think that's super nice. So you definitely should check her out. And I know she streams Friday afternoons or evenings sometimes, and usually I think Tuesday evenings, something like that. So give her just check her out, see what you think. I think you'll like it. All right, well, let's. Oh, it's a birthday stream. That's right, for Digital Seahorse. Why don't we just drop in and see what Digital Seahorse is up to, and we'll give her a raid. And we'll catch everybody later. And maybe we'll catch Studio Cornix later, because I'm usually her moderator. So, we'll see what Digital Seahorse is up to. Sometimes she's doing Minecraft, and sometimes she's doing some drawings. I've seen her draw diatoms before, so we'll give her a raid. And thanks again, everybody, for hanging out. And please check out all the streamers that I talked about. Also, do me a favor and follow my friend Pacific Plankton. She streams as well. She hasn't been on a lot recently, but she's a great microscope streamer. And if you like what you saw here, imagine somebody with an even nicer voice who looks at wiggly stuff all the time on her microscope and is super educated and friendly about it. And that's Pacific Plankton. Also, our friend Commander Shafar just hopped in. He does some games from his Xbox. You should definitely give the chef a follow if you like gaming. He's usually hitting things with a wrench or something. So, mature audiences for him. Okay, we're gonna raid. Thanks everybody, and we'll hopefully catch you next time. I'll probably be on Wednesday from the Scanning Electron Microscope. So, that's my plan anyway. Alright, bye.